In the year 2000, Awqaf South Africa was pioneered as an institute of Waqf and the empowerment of communities. South Africa faces a diverse set of challenges with a high unemployment rate and a stark divide between rich and poor, where electricity, hospital care and water shortages plague communities and where lack of education hinders progress. Awqaf South Africa is a catalyst for change. As a charitable endowment receiving organization, Awqaf invests endowment funds wisely and ensures that only the income generated from investments is used to fund a variety of community development projects. We are excelling in all that we do with the highest standards of ethics, integrity, and sincerity of purpose. From masjid development, imam empowerment to sports development, orphan support, food security, and surgery support, Awqaf South Africa is paving the way by investing in the future of communities and uplifting generations to come. Awqaf South Africa, creating a legacy of hope and
It is the Awqaf SA Grade 10 workshop, maths workshop that is happening here at Azhar High School in Athlone. Yes, you are going to ace your final maths examination, and we are here to make sure that you do so. Hosted in association with the Department of Basic Education, Thread Waqf, iSkill, and we are coming live from Al Azhar High School in Athlone. To our online audience, do make sure that you let us know where you are connecting from. We will not miss out on, so that you cannot miss out on the future workshops. Today we are focusing, as I said, on the grade 10 maths workshop. But just to not to eat your time, we will call upon Awqaf SA's Hassanain Abdullah just to give us a short brief. I believe it is the ultimate one for the year.
There we go. There we go. A warm welcome to all of our learners. Give yourself a round of applause there, online and in person there. This is the last one of our series of workshops for 2024, which will prepare you for your final examination. Awqaf South Africa on YouTube. Subscribe, like. Please hit us up in the comments. Let us know from which province, from which school you are connecting to us from. We are with you all of the way. We are going to be contributing towards providing quality education here in South Africa. Khalid and Romana will be taking you through the session for today, as well as Samit and Nasir on the AV technical. We will be sharing some more information about the Awqaf SA competition that will be opening, some hard cash that's available. So without further delay, we'll pass on back to Khalid. Please enjoy the session. The session is hosted on YouTube, so you can refer back to the session. Over to Khalid.
And that was Hassanain Abdullah from Awqaf SA, the project manager. Now, this project will not be possible without our partnerships from Thread Waqf. We know that last week we had Imran Jiwa, who was talking to us from South Peninsula High School, who was addressing us. So we need to thank our team, Somet and Nasser, who make sure that the AV, everything is running smoothly. Also for you online. As I have said, that let us try and make sure that we hit those comments so we know how you feel, what's the problem or what's going on, what's the mood online. Today is Sunday, so let us try and make sure that we cue that video with Romana all the way from Johannesburg so that we can get Mr. Kota going.
Flight directors go for launch. T minus 5, 4, 3, 2, 1. We have liftoff.
Vehicles pitching downrange.
Just before I give to you, we can't leave here this place without inviting a great man, the one who has made sure that he has hosted us with so much hospitality, and we are in this place. This is such an amazing place. We call upon the principal, of course, of Al Azhar High School, Mr. Ashik Mani, who will be talking to us, just giving a small motivation to the cohort of learners who are gathered here today, as well as those who are online. Mr. Mani, please come through. Welcome this morning to Awqaf SA.
Yeah, thank you, Khalid. Shukran, assalamu alaikum, everybody. And your presence here, despite the rain, means you are determined. You are determined to win. You are determined to succeed, and you are determined to have a better life for yourself, for your families, and for your kids. But you must start feeling like winners. You want to win. You can do math. You will do math, and you're going to start enjoying math. Once you enjoy math, it becomes easy. And if you have math, the world opens up. So you are the elite. Physics and maths. Not everybody can do that, but you have proven that you can do it and you will do it. So make the most of it. And if you've achieved it, walk out of here proudly. I can do it. And I've learned so much. And I'm so enthusiastic. And I'm going to have a bright future. Amen. You're going to succeed in your exams. Have your exams in mind, but also have your matric in mind. You're not just here for grade 10. And you also have your university studies in mind. That's where you're heading. So inshallah, you do your best. Feel free to ask any question, but start enjoying it. Enjoy something you would want to be here, like soccer. Enjoy this. I mean, all the best and enjoy it today. Thank you, Mr. Kota, and to Awqaf, Khalid, everybody who's making it possible. As principal, I'm very proud to be associated with you.
And that is Mr. Ashik Mani, the incumbent principal of Al Azhar here in Athlone in Cape Town. Mr. Kota, just yesterday you said that we had a beautiful weather and you were hoping that Cape Town stays like that 365 days a year. It seems like your dua was not accepted or something like
I
that.
think I jinxed it. No, but it's
Let's get us
beautiful.
going.
You know, Cape Town, the city, the mother city. Assalamu alaikum. Good morning, good morning, good morning. How's everybody? How's our grade 10 learners here from Slapstad? Is it Kapstad or Slapstad? Slapstad. Everybody is bright and fresh and early for day 2, reporting on duty. And all our online learners of Fense, Spectral Pal, all bright and fresh and early. I see Fazlan Palmer. Wa alaikum salam. She is from Darul Islam Islamic High School. Big shout out to you. And all the other learners. Otsile, Lily, Zipo Zintle, Yamkela. Wow, Alhamdulillah. Alhamdulillah. Giga Niga, morning, mana, awe on. Nabila Isaac, hi. Nuran, El Nagar, good morning. Sumaya Daya, hi. Assalamu alaikum. Welcome, guys. Salams, Mr. K. Farhan Subada. Hey, Mr. Subada, how are you, my friend? Right, myself and Mr. Subada, we go back a long way. Alhamdulillah. Guys, let's get started. You bright and fresh and early for day 2. We're starting with paper 2 as we promised you yesterday. We are starting with trigonometry, the one that is killing you, the one that is cracking you. But I promise after today's session, you're going to love trigonometry. You're going to wait for trigs. And that is the topic, inshallah, you're going to score the best in. Say Amin. Amen. All right, guys, without any further ado, without any further delay, please hit the like, hit the subscribe button on YouTube. Share this link with as many people as you can to get all the grade 10s from around the country to be part of this. And we're starting with past papers. So let's get into it, guys. Are you ready? Yes, Trigs, take a deep breath. Take out your scientific calculators, take out your exam pads, and let's get cracking. Let's go. Right, Bismillah. In the name of God, the most gracious, the most merciful, let's get started with the program. Okay, now guys, what's important for you guys to remember in Trigs? In grade 10, I just want to do a little bit of a refresher for you. In grade 10, what you want to do, the minute you see a 90, remember you only deal with 90-degree triangles. In grade 10, we only deal with 90-degree or right angle triangles. So with regard to right angle triangles, if we call this angle theta, an unknown angle like x, y, z, we call that angle our reference angle. Why? Because we're referring to that angle. So that is called our reference angle. The first thing you do when you see a 90-degree triangle, you label it. The side opposite is called our opposite. The side opposite our 90 degree is called our hypotenuse. And the remaining side is called our adjacent. So we know that for the whole of trigonometry, we're only going to be using SOHCAHTOA. These are our ratios. Sine opposite over hypotenuse, cos adjacent over hypotenuse, tan opposite over our adjacent. Okay? So the minute you get a triangle, step number 1, label your triangle. Label your triangle. I'm giving you some clues, some hints before we even get started. Remember that its simplest form is sine theta, cos theta, and then if you want to reduce, you want to simplify trigonometry, is always in terms of sine and cos. Even tan is converted to sine over cos. Even tan theta. So we got sine, cos, and tan. Now we also have what we call our reciprocal, very important. Reciprocal functions, the opposite functions. Reciprocal means the opposite. So cosec theta. Please remember this. I want you to take all this down. I want you to take all of this down because we're going to be utilizing these tools. This is our toolbox. This is our laws. This is our toolbox. It looks like tot box, but it's toolbox. Toolbox. This is our toolbox. Cosec is 1 over sine theta. Sec, not sec, not like foot sec, it's like sec. Sec theta, secant theta is 1 over cos theta. And cot theta is equal to 1 over tan theta. Cotangent, cosecant, secant. These are what we call reciprocal, opposite functions. Learn. Learn. Then we're going into our special angles. I'm giving you all the tools we're going to use first before we start with the past paper. So I'm giving you a complete overview so that you are equipped. These are your weapons. We are about to go to war. You can't go to war without weapons. And these are your weapons. Sure, I talk loud, ne? Yes, like, and a lot, ne? I get paid to talk. The more I talk, the more I get paid, I think. Hassan? Hunch? Per word. I get paid per word. Hint, hint, nudge, nudge. Put the dollars. Onliners, how are we doing? Take all this down. How's my beautiful students from across the country? Sipati, welcome. Stembiso, Tlapo from Woodbank. Wow. So we've got learners from across the country here. We've got Woodbank, we've got Northwest, Polokwane, Western Cape, KZN, Gauteng. Yeah, we get paid for speaking, word for word. Let's go, let's go, let's go. So you've taken all this down. Now we have what we call, what is the one thing that I left out? Let's see who knows their trigs. Which set of laws, which set of tools have I left out? Special angles, mashallah. Hey, mashallah, Habibi, come to Cape Town. Special angles. Now your special angles, guys, you can use your calculator, but it's good to remember them. But only thing, your special angles on your calculator, you don't want to give decimals. You want to leave all your special angles in its simplest third form or in fraction form. So no decimals. No decimals. So the first one, sine 60. Sine 60 is square root 3 over 2. So sine 30 is equal to a half. Now, cos 60 is the opposite of this. So cos 60 is a half, and cos 30 is the same as sine 60, root 3 over 2. Good to remember, good to know. Good to know. And then we have tan 30, which is equal to root 3 over 3. And then we got tan 60, which is equal to root 3. Sine 45, cos 45, sine 45 or cos 45. Both, you can either say 1 over root 2 or root 2 over 2. Root 2 over 2, or you can say your calculator will give it to you as root 2 over 2. 1 over root 2 is the same thing. There we go. So let me just block them out for you. that is sine, that is cos, tan 30, tan 60, sine 45, cos 45. There we go. These are our special angles. We're going to be utilizing them in trigonometry. And obviously, do not ever forget, because we're dealing with 90-degree triangles, don't forget Pythagoras. H squared is equal to x squared plus y squared. Right? The square on your hypotenuse is equal to the sum of your other two squares on your other two sides. Right. Come I teach you guys something quite. Come I teach you something new and something quite. We have also what we call Pythagorean triplets. Have you ever heard of them? Have you ever heard of Pythagorean? They sounds like a big word, né? Pythagorean. But I'm telling you, it will help you to become a machine in trigonometry. You know why? Let me show you what are Pythagorean triplets. Let me show you what are Pythagorean triplets. Right. In a 90-degree triangle, right, put your pens down, just pay attention. We know if this is 3, this is 4. What will your hypotenuse be? Now, some of you will go 8 squared is equal to 3 squared plus 4 squared. But you know it's part of your Pythagorean triplets. So let's do this. Let me erase this. Pythagorean. Let's write him out. Pythagorean triplets. Triplets means 3 sides. So if this side is 3, that side is 4, this side must be 5. Right? So 3 squared plus 4 squared is equal to 5 squared. That's your first. You don't even need to use a calculator. So when you see the one side is 3, the other side is 4. By virtue of the Pythagorean triplet, your hypotenuse will always be 5. So you don't need to use a calculator. It saves you time. So even when you're in matric or grade 11 and you see a triangle, one side is 3, other one is 4, the one is 5. If hypotenuse is 5, the other one is 3, the other one must be 4. Yes or no? Right. Anybody knows any other Pythagorean triplets? So my first one is 3, 4, 5, right? 3, 4 to get 5. Who knows of another Pythagorean triplet? Who knows of another Pythagorean triplet? How about 6, 8 to give me 10? 6 squared is 36. 8 squared is 64. 36 plus 64 is 100, and the square root of 100 is 10. So here's it. If the one side is 6, the other one is 8, the other one must be 10. Who knows another very popular one that's asked in all papers? So you'll either get one of these. How about 5, 12, 13? 5 squared is 25. 12 squared is 144. 144 plus 25 is 169. The square root of 169 is 13. Nice, ne? Are you guys following me? They're good to know. Now, if you double this till infinity, you'll get all the triplets. So 6 times 2 is 12. 8 times 2 is 16. 10 times 2 is 20. And you can continue that pattern. It's a geometric pattern for infinity. If you double to 12, 24, 16 will be 32, the next one. But you won't use that one so much. The most commonly used ones is 3, 4, 5, 6, 8, 10, 5, 12, 13. Your Pythagorean triplets. Good to know. Good to know. Good to know. The other one that is also used is 1 square root of 3 to give you 2. Because 1 squared is 1, root 3 squared is 3. 3 plus 1 is 4, the square root of 4 is 2. This is also a very popular one. 1 root 3 and 2, 3, 4, 5, 6, 8, 10, 5, 12, 13. These are what we call Pythagorean triplets. Remember them. Learn them. Get used to them. Right, onliners? Right. 5, 12, 13, chefs. Fantastic. Fantastic, Shebs. Well done, well done, well done. 5, 12, 13, 6, 8, 10, 3, 4, 5, 1, root 3, and 2. So there we go. We're done with the tools. Guess what? Time to fight. Are you guys ready? Take a deep breath. Safetla Mabitsela for Shoshanguve East Secondary School. Big shout out to you. Leila Bawa, Assalamu alaikum. Welcome, Roshni Islamic School in the house. Let's go. Right, so I'm erasing all of this. You've taken it down. Guys, we did tell you, for those of you who only joined us today, that these sessions are recorded on YouTube. So you can go to the Awqaf website on YouTube and you can watch this over and over until you master mathematics. Let's get started. I'm not doing it topic for topic. I'm going paper for paper. So it's as if today we are sitting and writing the final paper. Bismillah. Let's take a deep breath and let's go in. The first diagram, the first one that they give us is a diagram. There we go. Take this down. They give you that. Let's see what information they give us. They tell us that is 2. They tell us that is angle theta. And they tell us this is square root 3. Ha! Look at that. Doesn't this fall in one of our Pythagorean triplets? Which one? Wasn't it the last one I gave you? Have a look. Have a look. So even before we start, right, use the diagram to answer the following. So use the diagram to answer. The first one, sine theta. The second one, sine theta, cos theta. How many marks? 3 marks and 2 marks. Your first 5 marks for your paper. So what's the first thing we do, guys? We drop our 90 degrees. So let's go here. We drop our perpendicular against our x-axis. Always. Never against your y-axis. Come on, to complete this using Pythagoras, what must this be? 1. Isn't it part of our Pythagorean triplet? Or if you really want to go and do it, you can say 2 squared is equal to, we can call that x or y. Let's call that y. Right? We can say y squared plus root 3 squared. I'm using Pythagoras. 4 is equal to y squared plus 3. 4 minus 3 is equal to y squared. Y is equal to plus or minus the square root of 1. In this case here, it has to be 1 because it's above your x-axis. There we go. But it's also part of our Pythagorean triplet, so you could have saved yourself time. You knew the one was 2, the one was root 3, the other one had to be 1. Thumbs up? Good. All we do now, we use SOHCAHTOA to answer. Let's write. And you must write this in your exam. SOHCAHTOA. So we want sine theta. Sine opposite over hypotenuse. So sine theta is equal to opposite over hypotenuse. No problem. Write that out. Right. Now label it. That's your hypotenuse. No. Yeah, that's your hypotenuse. Let's just do this. Right. The side opposite your reference angle is your opposite. Hypotenuse, adjacent. Opposite over hypotenuse. Opposite over hypotenuse. 1 over 2. Full stop. Do not find the value of theta. They're only asking you to find sine theta. So sine theta is a half. That's your first 3 marks for Mahala. Free marks. Not 3 marks, free marks. Sadaqah. Sadaqah Jariyah. Zakat marks. Lillah. Number 2. Sine theta times cos theta. Come on, no brainer. Opposite over hypotenuse. Cos is adjacent over hypotenuse. 1 over 2. Adjacent over hypotenuse. Root 3 over 2. We're multiplying 2 fractions. Numerator times numerator. Denominator times denominator. Root 3 over 4. Game over. Your first 5 marks. Easy peasy. Lemon squeezy. Right. You all got that right. You all understand that. Onliners, how are we doing? Right, now we do trig substitution. Now we're going to substitute. So that's your diagram. Simple. Drop your perpendicular against your x-axis. Label it opposite, hypotenuse, adjacent. You've completed your diagram. Now substitute those values into what they ask you, and the problem is solved. It's as simple, straightforward, more easy than this, you won't get. Well done, Nabila. All good. Thank you, Spectral Pal. You guys are amazing. We love your feedback. We love you to continuously talk to us, so at least we know where we stand. You guys are our monitoring tool. Right, let's go to the next one, guys. Next one. If x equals 60, take this down. If x is equal to 60 degrees and y is equal to 45 degrees, find the value without the use of a calculator. Without the use of a calculator. So this is special angles. 60 and 45. What is this? In your mind, before you even write, you must tell yourself, they are testing me on special angles. So let's go. A half sine 2y minus open brackets 2 tan squared x over 2. It's not difficult. It's algebra. What is it? Algebra, which we did yesterday. Substituting and removing brackets. That's all. Cos x times cos x. For 6 marks, yo. Right, let's go. Let's do it together. Watch here. Many of you still don't know how to substitute in grade 10. Remember, when we substitute, we use brackets. Whenever you substitute, you must use brackets. So let's go. A half sine 2y. Y is how much? 45. Minus, open brackets, 2. Be careful here. Be careful here. Watch here. Put your pens down. This is going to be 10. X over 2. 60 over 2. And put another bracket there and put your square outside. That's the catch. You can't square 10, but you can square the whole angle. Remember that till grade 12. Now cos x. Cos times cos of x is 60. Right, let's simplify this, guys. Now that you see that the catch was there, the catch was there with the square. Let's go. So this is going to be a half sine 2 times 45 is 90 degrees minus 2 tan in brackets 60 divided by 2 is 30 degrees square. Don't forget the square. Cos 60. Now, special angles, a half, sine 90, use your calculator, sine 90 we know is 1. Sine 90 is 1 minus 2 times, what is tan 30? Tan 30 is root 3 over 3 squared. Cos 60 is a half times a half. What is that? Is that now trigonometry or is that algebra? Algebra. Let's do the algebra. Moving over to the side because I don't have space. A half times 1 is a half minus 2 into root 3 squared is 3 over 3 squared is 9 times a half. If you want to, just use your calculator here and give your final. Only here can you use your calculator. Or if you really want to, because these are all multiplied by each other, 3 over 9 is 1 over 3. Okay, look at this. In this bracket here, because you're multiplying, the 2 and the 2 will cancel. 3 goes into 3 once, 3 goes into 9 3 times. It's a half minus, what am I left with 1 over 3? A half minus 1 over 3, a half minus 1 over 3, a half minus 1 over 3, and we get 1 over 6. There's your answer. Huh? Yeah. Break will be 10:30. Break will be 10:30. But let's not worry about break. Let's finish this paper. Let's finish this whole component. And there we go. In fact, you could have used your calculator here. If you wanted to, you could have used your calculator from there to get 1 over 6. No problem. They wouldn't have known. But at least you would have shown all the steps. You would have got your full 6 marks. Trust me, you can't jump from there to your final answer. You have to show steps. Some of you, from the beginning want to just use your calculator. You'll get it wrong. Substitution. This is just pure substitution. And then what takes over? The algebra takes over. The algebra takes over. How are we doing, onliners? Did you get that right? 1 over 6, Nabila. Well done. Zubaida Ibrahim, love trig. Brackets. Fantastic. 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 Well done, Nabila. Nabila is on fire. I see a distinction coming. She's been answering all our questions. She's been the main brain since yesterday. You guys are absolutely amazing, guys. Alhamdulillah. You are working nicely. And this is from a past paper. So practice. Practice on this. Practice on your algebra. Practice substituting correctly using your brackets. Right, now they tell you determine the acute angle beta. Now you have to solve for beta. Now you got equations. So it shift. It's your second function key on your calculator. Amin, Nabila. Lots of love here from Cape Town and from all of us here. Right, let's go. Let's go, let's go, let's go. Right, now we're solving. So now you got trig equations. So this was special angles. So what did we do today? Let's just quickly walk through what we did. We did the diagram where we dropped the perpendicular. We did the trig substitution where you given an expression, you substitute special angles. So we did 2 big topics. The third topic, obviously you have to see in your paper, is a trig equation where you're solving for an angle. So let's say solve for beta. Come, solve for beta. Solve for angle beta. Right? Remember, that is called angle theta. That is called angle alpha. Don't forget that. It's just x, y, and z for angles. It's unknown angles. And then this is beta. Beta. If you're Afrikaans, you would say theater. Osmos theater. Alpha. Beta. Right, let's go. Question number 1. Sine beta minus 17,8 degrees is equal to 0,215. Number 2, tan 3 beta is equal to root 3. They're trying to catch you here. 3 sine beta over 2 is equal to 2,012. 3, 3, 3. 9 marks here. 3 marks, 3 marks, 3 marks. Now, let me explain to you something. Many of you still don't know this. What is standard form in trigonometry? Who knows what is standard form? Standard form. Standard form is a trig function, t for trig function, sine, cos, or tan. There you go. Trig function of an angle must equal to a fraction. Trig function of an angle, let's write it out. A trig function of an angle must equal to a fraction. Learn this. You need to know this. This is what we call standard form. Now, none of these, in fact, the first one is in standard form, second one is in standard form, last one not. Can you see? Watch here. So first, please, step number 1, check for standard form. So trig function of an angle is equal to a fraction or a decimal. That's standard form. Now you solve for the angle. You can't take the 17,8 there. That's a side. That's a degree. You can't add a side and a degree together, can you? No, you can't. Look at the second one. You can't divide by 3 and divide by... You can't divide an angle by 3 and divide a side by 3. You can't. But this one, to get it into standard form, we'll have to first divide by 3. So if you're good, you can start with this already. Right. In fact, to save us some time, I'm going to help you along the way. Let's answer these 3 questions together. Guys, I beg you, learn well. Right? You're going to use it in grade 10, 11, and 12. This is trigonometry, how to solve for an angle. So let's do the first one together. Here's your answers. I'm doing the answers here on the side for you. Question number 1. So sine beta minus 17, 8 is equal to 0,215. So your angle beta minus 17, 8 is equal to, that's your angle. Your angle is equal to, now go to your calculator. Make sure your calculators are on degrees on the top. Make sure your calculators are on degrees on the top. Now go shift sine 0,215. We get 12,415, 12,42, correct to 2 decimal places. Now solve for beta. So beta is equal to 12,42 plus 17,8. Beta is equal to 30,22 or 30,2 degrees. Learn. Do not. Some of you are going to take the 17,8 over on the other side first and then solve. You will get it wrong. You'll get 0 for the question. Are you all following? Thumbs up. Beautiful. Let's see you do number 2 and 3. Come on, guys. I did number 1 for you. Do number 2 and 3 on your own. Do number 2 and 3 on your own. Onliners, how are we doing, my dear friends? Psst. I see dead people. Are you dying? 30,22, Leila. Well done. Giga nigger. 30,22. My nigga giga. Fazlan, how are we doing, Fazlan? Daneo. Precious. Nice. Do number 2 and 3. So spectral Pell says B is equal to angle beta is equal to 20. I don't know. I don't have a memo. We'll be working it out together. Do number 2 and 3. And how also? Spectral Pell. And how? Okay. Let's go. Right. Number 2, tan 3 beta. Tan 3 beta is equal to root 3. Now we say shift tan root 3. So 3 beta is equal to shift tan square root 3. 60 degrees. So beta is equal to now 60 divided by 3. Yes, Spectrapel. Beta is equal to 20 degrees. Bravo! Yoo-hoo! 10 brownie points. Today we'll just give you brownie points. Last one. Who got that one right? Onliners, how many of you got number 2 right as 20 degrees? Precious got it right. Shoshanguve, Titetso. Well done. Yeah, how many of you got it right? Well done. Brilliant. Brilliant. Let's do the last one. Let's do the last one. So we have 3 sine half beta, or beta over 2 is the same thing, is equal to 2,012. Now divide by 3 first. Sine beta, get it into standard form. Trig function of an angle must equal to a fraction. So beta over 2 is equal to shift sine fraction 2,012 over 3. We get 42,1. So now I want beta on its own. I don't want beta over 2. You don't just take it over. What's the opposite of division? So we multiply by 2. What I do to the left, I do to the right. So beta is equal to 42,1 times 2 is 84,2 degrees. Done. And you got yourself 9 marks. 369. Easy? I told you Trigs is easy. I told you Trigs is easy. Right, let's go. Let's go. Jared van Skalwijk, you got it right. Well done. Lemochang, 84,2, like a boss. Right. Now find a value of the following expression without the use of a calculator, special angles. So here's your special angle for another. This is all from one paper, eh? We are completing one entire paper. In fact, we'll do 2 papers. I'm doing this one and I'll just choose a random other paper from a different province. This was a KZN one. Let's choose maybe we choose a Gauteng or Western Cape paper also to do. We'll do 2 complete papers for trigonometry, and that should take us right into break. We'd be done with trigs. That's how easy. You have to score full marks. 30 to 40 marks in your exam is trigonometry. Then your analytics, data handling, Euclidean, boom, your 100 marks. Easy. Yesterday, we did everything 80%, 90% guaranteed from paper 1. Learn your functions. Number patterns that we did yesterday, even the higher order ones. Those of you who weren't here yesterday, go back to the video on YouTube. Okay. Here goes. Are you ready? 10:30. Cosec 60. I'm not going to help you with this one. This one you're going to do by yourself. Over cot 45. Sine squared 45. For 6 marks. This is multiplied. If there's nothing between it, it means it's multiplied. Right, your special angles. Substitute correctly. There's some reciprocal functions here. Cosec and cot is your reciprocal functions. Let's see who gets full 6 marks here. That will give us 25 marks for what we've done already. Okay. Then, hey, they actually even gave us, I'm surprised, for grade 10, they actually gave some higher order questions here after this. Interesting. I haven't seen it before, but anyway, we're going to do it now. Go for it, guys. Go for it. Go for it. Go for it. So 17 and 25, 42 marks. 42 marks was only on trigs besides your trig graphs. Trig graphs was another 8 marks. So your 50 marks was trigonometry in this paper, year-end paper. 50, 50. Imagine you don't know trigs. You're going to be in big trouble. Right. Let's go, let's go, let's go, let's go. I'm just looking for other questions. The higher order questions here are crazy. There's 2 higher order questions, not difficult. It's just that they want to give you these higher order questions for those learners who they want to now say a cut above the rest. That will distinguish you between being a B student and a C student from an A student. Remember, your whole paper is not higher order. 80% is normal. Only 20% or 15% will be higher order. So don't panic. But try and get your higher order right also. Who's done? Pick up your hands. Show of hands. How many of you are done? 2 only. Come, guys. Come, guys. I'll give you another minute. I'll give you another minute. Huh? You get an answer of 4/3. I don't know. Let's see. Going once, going twice. Let's auction your answer out online. How many of you got 4/3? Wow, yes. Hendile. Mazamelela, 4/3. Well done, well done, well done. Do you all get 4/3? Look, he gets 4/3 here, they get 4/3 there. I'm assuming that you're right. Do you also get 4/3? So 4/3 going once, going twice, and online going thrice. Right, I'll accept 4/3. Let's check if 4/3 is the right answer. Right. After this, the higher order question. So get ready. After this, the higher order question. Get ready. Right. We know that tan 30, so let's just circle that. Tan 30 is square root 3/3. Cosec 60 is 1/sin 60 divided by cot 45 is 1/tan 45 times. They want to see the step. They want to see that you've converted it using your reciprocal functions. Sin squared 45 is sin 45 squared. I'm moving over to the side. Root 3/3 times. Now this, at this point, you can use a calculator. Say 1/sin 60. Hey, 1/sin 60, close brackets. And you get 2 root 3/3. Right? It's actually root 3/2. Remember something, sin 60 is root 3/2. So 1/root 3/2. So times 2/root 3. In fact, times 2/root 3. What you do to the denominator, you do to the numerator. So I'm just going to say times 2/root 3 all over. Tan 45 is 1. So 1/1 is 1. Sine 45 is root 2 over 2 squared. Let's check. Let's check. You're multiplying. So root 3 and the root 3 will cancel. So I'm left with 2 over 3 divided by root 2 squared is 2 over 2 squared is 4. Go to your calculator if you want to. 2 over 3 divided by 2 over 4, which is a half. And you are right. 4 over 3. Well done. Brilliant. Machines. Now you're going to get your 100%, inshallah. Well done. Onliners, those of you who got 4 over 3. My Lula Brenda, Tato, Tsitetso, Kiabetswe, Precious. Well done, all of you. Big round of applause for all of you. Come, guys, let's give them all a big round of applause. Because you're going to be using this till grade 12. That's why I'm so excited to see you guys getting this stuff right now. You don't ever forget this. Everything next year is going to be built on this. This is your foundation. We are plastering your foundation for 11 and 12. Okay? Sure. Now, let's give you the killer question that I asked you. And it's not difficult. Right, let's go. You ready for the higher order question, guys? So let's go. Well done to all of you. You guys are amazing and you guys are working so nice. MashaAllah. Well done. Right. Check this one out. The following is given. If 7 sine x equals 4 and x is less than 90, and take this down, tan y is equal to t. X and y are complementary. That means they add up to 90. Supplementary means that they add up to 180. Complementary means that they add up to 90. Find the value of t squared. No calculator. And with the aid of a sketch. And with the aid of a diagram. With the help, with the aid of a diagram. 6 marks, Baba. 6 marks. This one is going to test whether you are cut above the rest. Come, onliners. This is a higher order question. They don't always ask higher order questions, but maybe one or two questions they'll throw in. X, so sine x is equal to, that's not in standard form, tan y is in standard form. So they say with the aid of a sketch. So let's draw our diagram. I'm just drawing the diagram. I want to see if you can use your brains. Right. With the aid of a diagram. Let's see who's sharp. Let's see who is sharp. So you get marks for the diagram, guys. Give me an answer. Let's see, onliners, who gives me an answer? First right answer gets 50 bucks. And you will claim your prize from my man Khalid here next to me. Remember, those that we owed from our last program and this program, everybody will be paid by next week. After this, this is our final program for 2024. Everybody gets their e-wallets this week. Alhamdulillah. Come guys, come guys. Get X and Y in your diagram. Get X and Y in your diagram. A question like this can be asked in grade 11 as well. Wow. Ah, Nabila, you get 50 bucks, 33 over 16, and that's the correct answer. Well done, guys. Guys, let's give Nabila another nice round of applause. Nabila, you get 30. You even beat our on-siters here, bruh. Well done, Nabila. Yes, 33 over 16. That's your answer. 33 over 16. 33 over 16. I think maybe Nabila in a couple of years' time is going to take over my position and start training here, right? Hint, hint. New K-Way presenter, Nabila, inshallah, amin. Do maths for the rest of your life. Nabila is on fire. That's what we're looking for. Talent. Right, let's go. Right, the first thing we do, we call that angle X, and they're complementary, so that's angle Y. Because they add up to 90. Now, it's not in standard form. So they give you a mark for this. 7 sine X is equal to 4. So sine X is equal to 4 over 7. So sine of X, X being your reference angle, opposite over hypotenuse, 4 over 7. Right. Tan Y is equal to T. Tan Y equals T over 1. Right? Tan of Y. But now remember something. We're going to use Pythagoras to finish this off. To get this value here. To get this value here. Let's put I don't want to call it X and Y. Let's call it A for adjacent. So 7 squared is equal to A squared plus 4 squared. 7 squared is 49. 4 squared is 16 minus 16 is equal to A squared. So A squared is equal to 33. A is equal to the square root of 33. So that A is the square root of 33. Now, tan Y from this diagram. Tan Y from this diagram is root 33 over 4. Right? Remember, opposite, hypotenuse, adjacent. Now, Y is your reference angle. Is root 33 over 4. Right? They said find the value of T squared. So if tan Y equals T, and tan Y also equals to root 33 over 4, therefore, let's now deduce, therefore T squared is equal to this squared, root 33 over 4 squared. So T squared, root 33 squared is 33, 4 squared is 16. Your answer is 33 over 16. Well done. Well done, Nabila. Yamkela, well done. Toxic August, I hope you got it right. I hope you got it right. Okay, another higher order question. This one was for 6 marks. The next one is for 3 marks and 3 marks. Another 6 marks, another 2 higher order question just to get your brains working. So they're hoping you don't get a full 50 out of 50. You get at least 38, which is 76%, if you got these 2 wrong. Okay. We're moving on fantastic time. We're moving on fantastic time. Here goes next one. I hope you guys are enjoying it. Onliners, give us a thumbs up if you're enjoying today's session. If you're seeing things that you haven't seen before, or if you're learning things that you never learned before, or you're understanding certain things that you never understood before. Because that's the purpose of our workshop. Right, let's go. Here's another higher order question. If sine squared x plus cos squared x equals 1, simplify the following. Question number 1. 1 minus cos squared x minus sine squared x. Number 2, cos squared x. Each one is worth 3 marks, plus tan x times cot x plus sine squared x. 3 marks, mark allocation, 3 marks, 3 marks, total marks, 6. These are your higher order questions, but they're easy. The last one maybe rock your boat, rock your brain a little. This is not difficult, guys. Talk to us onliners. Give us a thumbs up if you're enjoying it. Super wow, super bow, superior bow. Well done, well done, well done. Subhada. Sharp, sharp. Double dolly. DD. Thanks, precious. Samama. Sharp, sharp. Monati. Nga. Mets is nga. Let's answer question number 1. Come, I hope you guys have done it. It's easy. It's not difficult. They want you to simplify. That means bring it in its simplest form. Bring it in it's easy. I swear it is easy. Come on. They're telling you that sine squared plus cos squared is 1. So instead of the 1 here, what can I put? So let me answer the first one. Instead of 1, instead of the number 1, what can I put? Sine squared x plus cos squared x. That's the number 1. That's the one. Minus cos squared x minus sine squared x. It's a no-brainer. Sine squared minus cos squared, 0. Cos squared minus cos squared, 0. Your answer is 0. Did you all get that one? Onliners, I hope you got that one. Now do the next one. Do the next one. Then we're going to do trigs on different planes. But it's not difficult. You're just dealing with 2 90-degree triangles. And that, inshallah, should take us right through until up to our break. So we got 42 marks already. We're going to guarantee 42 out of 50. Yes. Hendile. Question number 1, the answer is 0. Well done. Brilliant. Let's do number 2. Come on. Show me what you got. Show me what you got. So Sheb said the answer for question number 2 is 2. Is that correct? Is that what you're telling me, Shebs? Is that what you're telling me? I don't know. I don't have a memo. But I don't think we're right. We know we're right. Because there's only one way to do it. Brains, logic, common sense. If it's not making sense to you, you're not doing math. Or you're not doing it right. Number 2, cos squared x plus tan x times cot x plus sine squared x. Let's see. Cos squared x. Tan x is sine x over cos x. We know that tan is sine over cos. Cot x is 1 over tan x. Okay, now let me just show you something here. Let me show you something here. Let me show you. Guys, I want you to remember this. You know that tan x is equal to sine x over cos x. So cot x is the reciprocal function, is cos x over sine x. 1 over sine over cos will give me cos over sine. But if you remember this, tan is sine over cos, so cot will be its opposite, cos over sine. So times cos x over sine x plus sine squared x. Now let's get in the algebra. Let's see if there's any algebra available for us. We're multiplying here, sine and sine, cos and cos, so we're left with 1. And we know that sine squared plus cos squared is 1. Remember, they told us sine squared plus cos squared is 1. So my answer is 1 plus 1. Come, grade 10s, 1 plus 1 is? So clever. And the answer is 2. Lemokhang 2. Shebs, number 2 is 2. Well done, well done, well done, well done, well done. Amazing. You guys are en route to your distinction. Okay. Now, something that I need to quickly explain. Many of you don't understand what's the angle of elevation and angle of depression. Many of you are coming here on a Sunday morning, so you are suffering from the angle of depression. Let's elevate you. Can I raise? Right, let's go. So you all got that? I hope you took it down. Let's talk about quickly. Let me explain to you what is elevation. I'll give you the simplest, best explanation you'll ever find. There you standing. You're looking straight ahead at a wall. You're looking straight ahead at a wall. So always think of elevation and depression when you're looking straight ahead. Now when you're looking straight ahead, up, that angle is called your angle of elevation. And when you're looking straight ahead, down, that angle is your angle of, not the whole angle, only where you're looking from the dotted line down is depression. And obviously, you know, it breaks it up into two 90-degree triangles, so you got a 90 there and a 90 there. Take that down. Very important. Angle of elevation, angle of depression. We're almost there, guys. We're almost into break. We're going to do this last problem, and then we're into breakfast already. Our day is going to fly. We're going to come back. I'm going to do a little bit more. Then we'll do analytics. We'll go for lunch. We come back, and we finish up with Euclidean. And there's your 100% for your paper. Data handling command. Mean, median, mode. Simple stuff. Bar graphs. Ah, come on. Data handling is a walk in the park, guys. Right, so let's give you a diagram here. Take this diagram down. Here we go. This is from your past paper. This is from your exam. So they give you a diagram. And I know many of you have seen this before. So here goes. Take this down. Take it down with me. There we go. There's your dotted line. That means you're looking straight ahead. Right. This is point E. 90 degrees. S, M, H. The angle of depression of H from E. Here this. Right. Let's write it out here on the side. The angle of depression of H from E is 26,2 degrees. The angle of depression of M from E is 34,4. Okay, let's see. From the type, okay, so they tell you there's a boat here. They tell you there's a boat there, and they tell you there's another boat there. Two ships or two boats. This is a lighthouse. ES is a lighthouse. ES is a lighthouse. Okay, from the top of the lighthouse, 55 meters above sea level. From the top of the lighthouse, 55 meters above sea level. So we're going to assume that SH is the ocean, That's your lighthouse. From sea level to the top is 55 meters. Two boats, M and H, are sailing due east. Have angles of depression as shown. Calculate the distance. For 5 marks, calculate the distance between the two boats. Now remember, that will always be parallel to the floor. When you're looking straight ahead to the ground, will always be parallel. Even if they don't put it in, you can assume it. Right. So one question for 5 marks. Calculate the distance between the two boats. Calculate the distance MH between the two boats for 5 marks. Calculate the distance MH. Right. Let's go. Right. Now we need to fill out some information. The angles of depression of H from E. So the angle of depression, looking straight ahead down, of H from E is 26,2. So we got that. The angle of depression of M from E, of M from E, so that means that entire angle there is 34,4. Now, calculate the distance MH. It's a 5-mark question. I'm going to give you 5 minutes to try and work this one out. We have to use SOHCAHTOA, obviously. And when we're done with this, we are into break. Cook Sisters and coffee coming up. I just said it and there it walked in. Mr. Mani, is that our Cook Sisters? Oh no, it's not Mr. Oh, it's not. Mr. Saeed. Right, let's go. Okay. I'm just trying to think. If I got two 90-degree triangles here, guys. I got a small 90-degree and I got a big 90-degree triangle, right? I got triangle ESM, and if I find that length, so let's go. Let's look at triangle ESM. You can do that, right? That's S, that's M, that's E, right? This is 55. Now we know that this whole angle here is 34,4. That means this angle here, alternate angle is 34,4. That means this angle here is 34,4. That's my 90. I need this side here. So let's label our triangle opposite, hypotenuse, adjacent. Opposite over adjacent, I'm going to go with 10. 10 of 34,4 is equal to 55 meters over SM. And that's what I want to find. I want to first find out what is SM. Be careful now. You want SM on the top. Now in algebra, I want this on the top. So if I flip the right, I got to flip the left because I want SM on the top. So SM over 55 is equal to 1 over 10, 34,4. I want SM on its own times 55 times 55. So what is SM equal to? SM is 55 over 10, 34,4. SM is equal to 55 over 10, 34,4, 80,3. Fantastic. 80,3 meters. So this is 80,3 meters taken from my small 90-degree triangle. Now I'm going to look at my big 90-degree triangle and calculate SH. Then the big side minus the small side will give me MH, because that's what they want me to find, MH, the distance between the two boats. Right? So now let's look at the bigger triangle. Let's look at the big triangle. Now we are looking at triangle ESH. Now we are looking at triangle ESH. ESH. Now I want to calculate this whole side, SH. Now I know this angle here is 26,2, so this angle is 26,2. Remember, angle of depression there was 26,2. And there, and we got that as 55. We're going to go again with 10. We're going to do exactly what we did here. We're going to do exactly what we did here to find SH. What do we want to find? What do we want to find? SH. We found SM. We now want to find SH. So 10 of 26,2 is equal to 55 opposite over adjacent. So SH, let's just go here, SH over 55 is 1 over 10, 26,2. SH times 55 times 55, SH is equal to 55 over 10, 26,2. SH is equal to 55 over 10, 26,2. 55 over 10, 26,2. 111,77, 111,8. So therefore therefore MH, that's what they want us to find, is 111,8. Hey, what the hell am I doing there? 111,8 minus 80,3. And here's your final answer coming up. 31,5 meters. Excellent. Well done. Can you see how we use trigonometry to find distances? Can you see how we use trigs to find distances? Guys, it is now, for the first time ever, we finished off at least 2 minutes or a minute earlier. It is now 10:25. Everybody's hungry. They want their kusistas and coffee. I'll see you guys back in here 11 o'clock for session 2. Nice round of applause for all of you. Go and enjoy your breakfast, guys. 11 o'clock on the dot. We start with session 2. You don't want to miss it. Enjoy your breakfast. Well done, Lemokhang. Well done, Superior Bao. Lumko, well done. You guys are amazing. Nabila again. Well done, well done, well done. A bit late. Did they kill my mic? Oh, they did. Are we good to go? We are back, we are back, we are back. Hope you guys enjoyed your coffee break, your tea break, 30-minute break, and we are back. We are back. Welcome back, grade 10s. We started with trigonometry. We are now going into trig graphs. And then we're going to do, I'll take out another paper and we'll see if we can do some more trigs from there as well. Okay? So let's get started. Welcome back, onliners. Are you all ready and fired up and fueled up and amped and pumped and ready to carry on? Let's check out if our onliners are back in the house. Karabo, are you in? Thailand, are you in? Lulama, are you in? Just hit us up in the comment section so we know you guys are all ready. Let's go, let's go, let's go. All right. Khalid, everything, all systems go? All systems go, guys. There's Layla. Layla back in. Back with another bang, another banger. Let's go. Okay. We're starting with trig graphs. We're starting with trig graphs. Now, what's important for you to know is that you got the sine graph, the cos graph, and the tan graph. Now, to help you to remember, S for sine, the sine graph starts at 0. The cos graph, C for cos, cuts first. C for cos, C for cuts first. And the tan graph has got asymptotes. S sine starts at 0, C cos cuts first, and tan's S. Right? Asymptotes. Where are your asymptotes? At 90 degrees and 270 degrees. Okay? Important. Important. Take this down. So just remember, sine graph starts at 0, cos graph cuts first, and the tan graph has got asymptotes. Okay. Now what's important, graph f of x is equal to, let's say, 2 sine x. Or let's say 3 sine, yeah, so let's say 3 sine 2x. Right. That value in the front, that coefficient in the front tells you the amplitude of the graph. Another word for amplitude is your maximum height. It also gives you the range. And that will give me the period of a tan graph. Because a sine and cos graph makes its appearance every 360 degrees, and a tan graph makes its appearance every 180 degrees. So this is the background knowledge that you need for these graphs before we even commence. Before we even commence, this is the background knowledge that you need. Do you guys have sound? Can you guys hear me and see me clearly? I see there Nabila Esak says no sound. Are we all good? Nabila, can you hear me and see me? Everything all clear? All good? Give us a thumbs up if everything is all clear for you. You didn't hear the past 2 or 3 minutes. Is everything all okay now? Is our sign okay? All right. So let's just go back. All right. So you want me to repeat that? Let me repeat that for you. Let's take all this out. This is where we stopped. Just remember that 90 degrees divided by that number there tells you the step of the graph, the degree change. Also, 360 degrees divided by that number will give you the period of the graph for the sine or the cos graph. But 180 divided by that number will give you the period of the tan graph. And what I just said is that the sine and cos graph makes its complete cycle every 360 degrees. The tan graph makes its cycle every 180 degrees. Right. Then we have a shift up or shift down, plus Q, plus Q. So A sine, let's just go. I'm just giving you the standard form here. Let's go here. Let's say y equals A sine BX. So we said that's your amplitude. Just going through it again one more time. 90 degrees divided by your B value is equal to the step of the graph. 360 degrees divided by your B value is equal to the period of the graph. And then the Q value plus Q. That Q value is whether the graph is either going to shift up or down. So it's important that you understand every single part, every component of that equation, because everything represents something. Okay? Good. So let's ask you to draw two graphs. Okay, in fact, let's draw a sine graph, a standard sine graph, a standard cos graph, and then a graph with a shift up or a graph with a shift down. Okay, so if I told you that f of x is equal to 3 sine x minus 1. Right. And let's see if we can sketch this graph. Okay, let's first draw a 3 sine x graph. Let's first draw a 3 sine x, then we'll do a graph with a shift up or a shift down. For x being an element of, let's say, minus 90 to 360 degrees. Now, this here is called our restriction. And another word for our restriction is called our domain. It's not the period of the graph. It is the domain of the graph. Okay, so step number 1, when you see a graph like this, the first thing you're going to do is draw your axis. There we go. X-axis, Y-axis. So let's all do it together. That's your y-axis, that's your x-axis, that's 0. Now we go 90, 180, 270, 360, that's your positive. Now remember, it starts from minus 90, so we got there minus 90. 90, 180, 270, 360. There we go. It goes up to 3, 1, 2, 3, and down to minus 3 or negative 3. Now, we need to check. 90 degrees divided by that number. 90 divided by 1 equals 90. That means that this graph is going to make a change every 90 degrees. It's a sine graph, so it starts at 0. It's positive, so it goes 0 up, not 0 down. Are you all following me? Grade 10s, are you following me? Good. 0 up. So every 90 degrees, it makes a change. So it goes 0 up, it turns at 90, Start at 0. You're not starting at minus 90. You'll just continue the pattern. But you start at 0. Goes up, turns at 90, cuts at 180, turns at 270, stops at 360. Let's draw the graph. Goes up, 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 turns, comes down, cuts, goes below the line, turns, and stops. And it continues to minus 90. So you continue with this to minus 90. You don't start off at minus 90. You start at 0. You start at 0. You start at 0. I think I need new batteries. Okay? There we go. Your graph is fully sketched. Your graph is fully sketched. Let's draw a standard cos graph. Onliners, we okay? Give me a thumbs up. Are you okay? Are you understanding? We start at 0 and it's a sine graph, so it starts at 0 and it goes 0 up. Now let's draw a cos graph. Let's draw a standard cos graph. Then we're going to go, after we do all this, after I explain, then I'm going to take the one from the past paper. Here they gave you the graph. So sometimes they'll ask you to sketch. Sometimes they will give you the graph and they will ask you questions on the graph. Okay. We're just changing batteries here. Is equal to 3 cos x, for x being an element of minus 90 to 360. Thank you, Khalid. Sketch the graph. Right, let's do it together. There's our axis. That's 0, 90, 180, 270, 360. And it's going to go down back to minus 90. The graph was 3 and negative 3. It's a cos graph. So it starts at your amplitude. It starts at 0, but at your height, not 0 on at your origin. It starts at your height. It cuts first. So we start here. 90 divided by 1 is 90. That means it's going to come down here. It's going to cut at 90. If that number is 2, then it will be 90 divided by 2. That means the graph will cut at 45. But it's cutting at 90, turns, cuts, stop in the air there, and it will continue. All right, so let's draw it here. Come down as a curve. Comes down, it cuts, it turns, it cuts, continues up, 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 up. It stops there. And we just continue the pattern on the opposite side. Again, I'm telling you, the graph starts, for your standard graph, the graph starts on your y-axis. It doesn't start at minus 90. Many of you get confused and you try and start the graph at negative 90. Wrong. It starts on your y-axis. Now they can ask you, what is the amplitude of the graph? So what is the amplitude? 3. What is the range of the graph? Negative 3 to positive 3. What is the domain of the graph? X less than or equal to 360 but greater than or equal to minus 90, taken from there. What is the period of the graph? 360 divided by 1 is equal to 360 degrees. 360 divided by that number gives you the period. Right. They can also ask you, this is graph G, for which values of x is g of x greater than 0, g of x greater than or equal to 0, g of x less than 0, g of x equal to 0. Now, greater than, what does greater than mean? Above. What does less than mean? Below. What does equal to mean? Where does the graph touch the x-axis? Take that down. So where is the graph greater than 0? Where is it above? It's above at 2 points. It's above there and it's above there. So you're going to have to give 2 answers for that. Right. So we're going to say for x less than, there's no equal to sign, less than 90, but greater than minus 90. That's the first place where the graph is above your x-axis. And then between 270 and 360. And then for x less than 360, but greater than 270. You have to give both solutions. Onliners, you following? Onliners, are you following? Are we good? You need to learn this. You'll see it's coming. Now, where is it greater than or equal to 0? Now, there's a reason why I gave you both of them. It's the same answer, only thing now this one got an equal to sign. For x less than or equal to 90, but greater than or equal to minus 90. Or for x less than or equal to 360, but greater than or equal to minus 90. Where is g of x less than 0? Where is graph G? Underneath. So it's underneath here. Where? Between 90 and 270. There's no equal to sign. Less than 270, but greater than 90. And they 2 marks each. It's marks you don't want to throw away. And where is g of x equal to 0? Where does it cut? Where does it touch? So you're going to say at x equal minus 90, or at x equal 90, or at x equal 270. There we go. Right. Where is the graph increasing or decreasing? Very important. Right. Where is the graph? Remember yesterday we did in functions, where is the graph increasing and decreasing? Remember that we did a negative parabola. Then I told you we just draw 2 tangents on the sides. Né? So for us to determine, with a tangent with a positive gradient is increasing, a tangent with a negative gradient is decreasing. So now let's do this. Where is this graph increasing and decreasing? Come. For which values of x is this graph increasing or decreasing? Let's go here. I'm just erasing that. Right. For which values of x is the graph increasing or decreasing? Very important. 100% you're going to be tested on this. So, watch here. Watch here, guys. I'm just going to draw tangents here on this side till the turning point there. So, I'm going to draw a tangent going there. We know that's got a positive gradient, so it's increasing. Then, I'll draw coming down here. I'll draw a tangent coming around until this point here. And that's a tangent with a negative gradient. And then I'll draw another tangent on this side here. It's increasing again there. We know this point here is 180. That's 0, 90, minus 90. Right. Increasing with a positive gradient. It's from negative infinity up to 0. So for x less than, from x less than 0, that's where it's increasing. All your x values less than 0. Or increasing between, for x, right. But in this case here, just for this specific graph, for x less than 0 but greater than 90. Right? Because remember the graph stops here. The graph stops here. But greater than minus 90. So let me just write this out. So in this graph, for x less than 0 but greater than minus 90, that's where it's increasing. Or it's also increasing between, for x values between 180 and 360. For x less than 360 but greater than 180. Increasing. We don't know equal to signs. No equal to signs. Because at that point, it's a turning point. So it's not at your turning point, it's not increasing or decreasing. Now decreasing will be between 0. Remember all these values, 0 and 180. X less than 180, but greater than 0. There we go. That's the values for which the graph is increasing or decreasing. All right. We all okay with this? You ready for the one from the paper? All right. Let's throw you into the past paper now. Very important work, guys. Very, very, very important work. Nabila saying still no sound. Can you guys hear? You guys got sound? Coming through? Everything all okay? Is it better? No sound. Superior Bow says, just check your internet connection, Nabila. Just check your internet connection. I'm getting sound from everybody else. So just check your internet connection. Maybe just go out and come back in. There is sound. Thank you, Jared. Thank you, Yahya. So, Nabila, I think it's just your connection. Thank you, Spectral Pal. Okay. Excellent. Thank you, Musa. Thank you, guys. Thank you, guys. Thank you, guys. Let's go back. Right, here goes. Let's clear this. Let's clear this. And let's give you the one that's in the paper. Here we go. Get ready for action. So they give you a graph that goes like that. They give you a graph. Here's your axis. Let's take it down. That's your y-axis. That's 0. That's your x-axis. Let's see. So it goes up to 1 and 2. 1, 2. Minus 1, minus 2. Let's go 90, 180, 270, 360. Let's go 190, 180, 270, 360. They give you the graph. The graph from 1 goes like this, cuts at 90, turns at 180, and minus 1 goes up. Guys, just have a look at this graph before we even tell you what graph is it. What graph is this? Is this a sine graph or cos graph? Cos graph. Right. Let's have a look at this, the next graph. So they give you two graphs together. The next graph that they give you starts at 0 going down to minus 2. 0 going down to minus 2, cutting at 180, going up to 270 and 2, and coming down to 360. Okay, let's go. From there, down, down. Whoa, no. There we go. There we go. Okay, this is graph G. This is graph F. The following graph represents f of x is equal to a sine bx, and g of x is equal to b cos x, for x being an element of 0 to 360 degrees. Right, question number 1. Find the values of a and b. Find the values of a and b. Number 2. For which values of x will g be decreasing? For which values of x is graph G decreasing? Number 3. The amplitude of f. Question number 4. The range of f. Right. And for which values of x is f of x? For which values of x? Now, question number 5. For which values of x is f of x less than or equal to 0? Right. So here we go. And that gives you another 8 marks. So the 42 from the trigs plus the 8 here is going to give us 50 marks for trigonometry. Okay, yeah. Sorry? Sorry? Where's 50? Where? For which value or values of x is f of x less than or equal to 0? Where did you see? Where was the 50? Where do you see a 5? Right, let's go. Let's go. Right, let's answer question number 1. Find the values of a and b. So there's a, there's b. So can you see how important is it that I had to show you what did a mean and what did b mean? What is a? Now f. Let's look at f. Right. F is a sine graph starting at 0 and it's going. So a equals. It's going 0 down. It's going 0 down. So it's negative. And to what number does it go to? 2. So a equals minus 2. Let's go back to our, let's go back there. A is equal to negative 2. What is b? It's coming down and it's turning at 90. 1. Very good. How did we get b? 90 degrees divided by b is equal to the step. So 90 degrees divided by b is equal to, what's the step of the graph? 90 degrees. So 90 divided by what? So therefore b is equal to 1. Because 90 divided by 1 is 90. So it's minus 2 sine 1x. You don't need to put in the 1, but it's good to have it. Right? No, but now the question is, let me just go back to the question here. Oh, it was a sine x. Okay, sorry. Okay, they didn't want us. B was this value here. B was this value. It wasn't the step of the graph. It wasn't, that wasn't A, that wasn't B. B is here. Okay, never mind. Let's just go back here. So B, in this case, B cos x. B is part of, B is my cos graph, and my cos graph starts at 1. So in fact, B is equal to 1 still. Right? B there is 1. 1 cos x or just 1? Right? There we go. So there we go. You got your first 2 to 3 marks. Question number 2. For which value or values of x is g decreasing? Let's look at graph G. G. Decreasing. That means, let's draw our tangents quickly. Graph G. So that's decreasing till there, till 180. And it's from 180 up, it's increasing. So we want to know where it's decreasing. For which values of x? Very good. So it's between 0 and 180. For x less than 180, but greater than 0. Put a tick there. You all understand that? 2 marks also. Right. Question number 3. The amplitude of f. Amplitude of f. Graph f. The amplitude is 2. Number 4. The range of G. The range of G. Negative 1 to 1. Oh, sorry, it was the range. The amplitude of f, the range of G. Sorry, the range of G. They wanted the range of, just change it there. Question number 4 was the range of G. For which value or values of x is f of x less than 0? So it's negative. Where is f negative? Where it's below your x-axis? Let's check. Let's answer question number 5. Is f of x, let's look at graph f, below your x-axis would be all of these values here. There's an equal to sign. So you'll say for x less than or equal to 180, but greater than or equal to 0. Done. Full marks. There's your 50 marks, guys. 50 marks for trigonometry. I just want to have a look at something else. Let's look at Gauteng November exam. Let me see if there's anything. I just want to blast you with a couple of trick questions. See if you can get that one right. Let's check if it opens. There we go. Paper 2, question paper. Let's open up this paper. I'm now doing November 2023 exemplar, but you don't need to worry about it. I'm just going to give you the questions. Okay. Right. So quickly, guys, here we go. Your graphs are done. I'm sure you all understand your graphs now. Okay, if they asked you to shift the graph up or down, let's just wrap up with that. If I told you f of x is equal to 3 cos x minus 1, for x being an element of 0 to 180. Let's see if you can sketch this graph. Right? I'm wrapping up with this. Let me show you how it's done quickly. This is our domain. Our domain is 0 to 180. Right? I just want to tell you the domain of the graph. The domain, x less than or equal to 180, but greater than or equal to 0. The period of the graph is still 360 because 360 divided by that number. So the period of the graph is 360 degrees. Right. The range of the graph, we'll have to calculate that range of the graph. Now remember, your normal range would have been from -3 to +3. Right? Now minus 1. Minus 1. So now you minus 1 there and you minus 1 there. So the range of your graph will be from -4 up to 2. Good. You have to include the shift. Right, now sketch the graph. Let's sketch the graph. Right, pay attention. Let's all do it together. Now, this is how I want you to do it. Right, put your pens down. Put your pens down. Let me show you how it's done. 0. So we're going to go 3. 1, 2, 3. -1, -2, -3. And because it's 1 down, we're going to go right down to -4. Right, now the period is still, and the step of the graph is still 90. So we're going to go 90, 180, 270, 360. Right, now forget about the shift. Let's draw the 3 cos x graph. The origin, this is what we call the mother graph. Right, so the mother graph, because it's cos, it's going to come down here. It's going to cut at 90. It's going to turn at 180 and -3. We're drawing the graph without the shift. We're drawing first the graph without the shift. Now we shift the graph 1 unit down. So now we say, instead of the graph, now you just tell yourself instead of. Instead of your graph starting at 3, now remember it stops at 180. So we got to stop the graph at 180. Check your restriction. Just stop the graph there. Right. Instead of your graph starting at 3, it's now going to start at 3 minus 1, which is 2. Right? Now wait, instead of your x-axis being at 0, watch here. Watch here, guys. You have to do this. Draw another, even your x-axis drops 1 unit down. And put your new markings directly below or above your old markings. So instead of your graph starting at 2, now you follow your new markings, guys. Instead of your graph starting at 3, it starts at 2. Instead of it dipping at -3, it's now going to dip at -4. So basically the graph is just going to go like this. It's going to go down like that. You're following your new markings. Don't worry about your old axis. Your new markings. And it's going to stop there. It would have continued, but our restriction stops the graph. Okay, you can clearly see it's 1 unit difference. Now you erase. You only leave original axis and final graph. So now that means we need to erase everything else. So we erase the mother graph. That comes out, that comes out, that comes out, that comes out. All this is out. And we take out that axis. We have to leave our original axis. Take that out. Take all that out. And there we go. There we go, guys. There we go. That's 80, 180, 270, 360. We're going to stop it at 180, and that is 90 degrees. That is -1. And there we go. We're done. That's graph F. That's a graph with a complete shift. So you draw the mother graph. You draw your new graph. You erase the mother graph. You only leave the original axis and your final graph. Are we good? All understand this? Excellent. Right. Let's just bomb you with some questions, trig questions from another past paper. Right. Onliners, how are we doing so far? All good? All good, all good, all good? Low on energy. Are you crazy? Still fired up, Leila. Low on energy. Let's go. Right. So we've got that. You've understood that. Let's go, let's go, let's go. Right. Question number 1. They say calculate theta. Here we go. Take this one down, guys. Calculate the value of theta if 3 sine theta over 2 minus 20 degrees is equal to 0,85 and theta is less than or equal to 90 but greater than or equal to 0. That means it's in your first quadrant. Right. Calculate theta. Remember, standard form first. Like we did earlier this morning, get it into standard form, then solve. This whole thing is your angle, guys. This whole thing is your angle. That's your angle. Come on, liners. Get it right. Then I'm going to give you another one where your cast diagram, ASTC, you guys did that in school? First quadrant, second quadrant, ASTC. We're going to end off with one like that. Right, so how do we do this? The first thing we're going to do, we're going to say sine theta over 2 minus 20 is equal to 0,85 divided by 3. So theta over 2 minus 20 is equal to, now go to your calculators. Shift sine fraction 0,85 over 3. Remember, we have to now use the shift key because we're looking for an angle. 16,45 or 16,46. Now we solve for theta like a normal equation, guys. So take the 20 over. So theta over 2 is equal to 16,46 plus 20. Theta over 2 is equal to 36,46. So theta is equal to times 2 times 2, 36,46 times 2, 72,92. And you will get another 4 marks for that. 4 marks. Last question. Last question. Now that you've understood trigonometry, after you've mastered whatever we've done today, you can now go to all your past papers over, let's say, go back 5 years, different provinces. Work out their past papers, have their memos, check where you're going wrong, make sure you don't make those mistakes in your exams. Simple as that now, because now you understand the work. Last one. Last one. Right, watch this one. If 5 cos beta is equal to minus 3 and beta is less than or equal to 360 but greater than or equal to 180, with the aid of a diagram, find the value of question number 1, cos beta, and number 2, tan squared beta minus cot squared beta. 3 marks and 3 marks, total marks 6. You have to use a diagram for this. Let's see who gets 6 marks here. This is the last question. Let's look at our time. How's our time? quarter to 12. After this, immediately, I'm going to take one big example from this past paper. We're going to work out the whole analytics model, and that will take us through to lunch. We come back from lunch, and we're going to crack Euclidean. Let's see. Work this one out. Khalid, you can take over for 5 minutes. I'm going to take a 5-minute bathroom break. I'm going to take a 5-minute comfort break. I want you guys to work this one out on your own. I give you 5 minutes to do it. I come back in 5 minutes. We work out the memo. Enjoy this problem. Learn it. Know it. Get this one right. 100%. You're going to see something like this in your exam. Thanks, Khalid. Talk to our learners there. Negative 4 squared is 16 over 9 minus 3 squared is 9 over 16. So 16 over 9 minus 9 over 16. Your answer is 175 over 144. Let's double check. Did you all get 175? They got no sound. Sorted out. 175. How many of you got 175 over 144? Well done, well done, well done, well done. Nabila, did you get that? 175 over 144. Is that what you gave me earlier? Let me just go back. Why does the sound keep on coming and going? Who? If I? Okay. There we go. There we go. 175 over 144. Fantastic. Well done, well done, well done, guys. MashaAllah. Well done. Excellent. 175 over 144. 16 over 9 minus 9 over 16. And there you go. You'll get full marks for this. Right. Let's now go and do the analytics component from this paper. And how many marks was the analytics here? 18 marks. Here's 18 marks, guys. So put the heading analytics. We're done with trigs. Inshallah, you're all going to get distinctions in trigonometry now. 50 out of 100. You're going to get at least 50% of your paper. Here's another 18. So that means 70%. If you only answered, if you only got all your trigs right, your trig graphs right, and your analytics right, you got 80% of your paper. You got 80%. Right, let's go. Take this diagram down. So guys, you have to get a distinction in mathematics. Take this diagram down with me. Okay, so now they give you a graph that goes, they give you a line that goes like this. They give you a line that comes down there. They give you a line that goes across there. They give you a line that comes across there. And they give you a line that goes there. There we go. There we go. There we go. There we go. Let's go. Let's label this graph. That's 0. That's your x-axis. That's your y-axis. This is not trigonometry. We are now into analytics. Point P, 2 and 9. That line is parallel to this line. And that line is parallel to that line. So what does that make this? A parallelogram. That's O. This is point A. This is R, N and negative 13. Take this down. N and negative 13. This is that's 90 degrees. And this is the point T, 10 and negative 3. And this is M. Right. In the diagram, P2 and 9, blah, 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 are vertices of a parallelogram. Palm. PMT is a straight line. M is the midpoint. That means that is equal to that. M is the midpoint. M is the midpoint. They tell you that. Right. And this is perpendicular. Right. Question number 1. Find the length of PT. The length of PT. Question number 2. The gradient of PT. Question number 3. The gradient of AR. Question number 4. The coordinates of M. Question number 5. The equation of PM. This is 18 marks in total. Show that N equals 5. No. N can't. Oh, n is our x value. Can n equal to 5? No. Maybe they mean negative 5. Let's just see. I think they made a mistake in the paper. They said show that n equal 5. N is the x value and it's on the negative side. There's no way that n can equal to 5. But it can equal to negative 5. Let's see. Calculate the area of triangle RMT. Calculate the area of triangle RMT. Right, total marks, 18 to 20 marks. Just double checking here the mark. Yeah, the paper is 2 hours, 100 marks. That means 50 plus 18, 68. Maybe 20 marks here, 70%. Without even doing your data handling, without even doing Euclidean, you got 70% for your paper. How difficult is it to get your 80? Come on. Now for analytics, we need to know your formulas. Distance formula, gradient formula. Midpoint formula, equation of a straight line. That's all. Parallel lines, gradients are equal. Perpendicular lines, the products of the gradients are equal to -1. You all know that by now. Area of a 90-degree triangle, half base times perpendicular height. As simple as that. Come, I'm sure you guys can get full marks here. Without me even having to do this for you. You can do this by yourself. Right. The answer to question number 1, the length of PT. So PT, you need to know your distance formula, the square root of x2 minus x1 all squared plus y2 minus y1 all squared. We're looking at PT. So we got P's coordinates, we got T's coordinates. So PT is equal to the square root of x2, let's call this x2, y2. So 10 minus 2, 10 minus 2 squared plus minus 3 minus 9 squared. So PT is equal to, go to your calculator, the square root of 8 squared is 64 plus minus 12 squared is 144. Your answer is 4 root 13 or 14,42. 4 square root 13. So PT is 4 square root 13. That's PT. Right. Answer to question number 2. The gradient of PT. So the M of PT is equal to, put your formula in, y2 minus y1 over x2 minus x1. PT, y2 minus y1 over x2 minus x1 minus 12 over 8, which is equal to minus 4 goes into there 3 times, 4 goes into there 2 times. Your M of PT, the M of PT is equal to minus 3 over 2. And there we go, we're done. So you got full marks, full marks. The gradient of AR. Come on, that's easy. The gradient of AR is also equal to minus 3 over 2. Why? These two lines are parallel. AR is parallel to PT. Therefore, the gradients are equal. No calculation for that one. No calculation for that one. The coordinates of M, the midpoint. The coordinates of M, the midpoint. So we're answering question number 3. No, question number 4. M, the midpoint, is x1 plus x2 over 2, y1 plus y2 over 2. So the M lies between P and T, so x1 plus x2 over 2, y1 plus y2 over 2. This is equal to 12 over 2 is 6, and then 3, right? 9 minus 3 is 6. 6 divided by 2 is 3. So the coordinates of M is 6 and 3. So M, the midpoint, 6 and 3. Notice what I do. The minute I get an answer, I go back to my diagram and I write it, because I'm going to be utilizing the values from my diagram in proceeding questions. Right, grade 10s? Good. Right, get me the equation of PM. Come on, get me the equation of PM. Y is equal to mx plus c. The equation of PM. The equation of PM. The equation of PM. I'm just erasing here because I need space. I want the equation of PM. What number was that? Question number 5, ne? The equation of PM. Right. Now what you can do, firstly find the gradient of PM. We got the gradient of PM. The M of the line is equal to, we got it there, negative 3 over 2. So now we can use y equals mx plus c. Y equals mx plus c. Y equals minus 3 over 2x plus c. Now we can use any coordinates, p's coordinates or m's coordinates. I'm going to use p's coordinates, 2 and 9. Why? To find c. That's x, that's y. 9 equals minus 3 over 2. What is x? 2 plus c. Let's solve for c. This the algebra now. 9 equals 2 and 2 will cancel. Minus 3 plus c. 9 plus 3. 9 plus 3 is equal to c. C is equal, 9 plus 3 is 12. Take the 12, put it back into there. Here's your answer. Y equals minus 3 over 2x plus 12. That's the equation of line PM. We all okay? Onliners, how are we doing there? All got it right? Minus 3 over 2x plus 12. Talk to me, onliners. Jared, got it right? Mr. Charles? Are we all good? Now show that n equals negative 5. Show that n equals negative 5 and calculate the area of triangle RMT. Thanks, Aman. Thanks, Alia. Thanks, Spectral Pal, Layla, Jared. We all good. Lovely. Do the last two. Get them right. And we got 70% for paper 2. We have just scored today 70% for paper 2 already. Meaning that even if we just did our data handling or stats, would have got 80-85%, even if we left out the whole of Euclidean. Say we didn't even touch Euclidean, we would have got our A for the paper. We have just secured our distinction for paper 2. Yesterday we secured our distinction for paper 1. Today we're securing our distinction for paper 2. Make sure you know your work. Thanks, Jared. Thanks, Musa, Nabila. All good. Lumko, let's go. Right. We are now, show that n equals negative 5. Right. What is the relationship? Right. Now we need to look at relationships. Okay, let's talk. We know that the m of this line is equal to minus 3 over 2. We know the m of this line is also equal to minus 3 over 2. I'm just trying to think. Okay, we don't have A's coordinates, right? We don't have A's coordinates. All right, let's just go. The m of AR is equal to y2 minus y1 over x2 minus x1. The m of AR we already got is negative 3 over 2 is equal to, but now we're going to have to, I'm just trying to think, is there, besides using the gradient, could we have used something else? I'm trying to think, look, I'm just give me a second. I know I can get it using this. I'm just trying to think, can there be another method? Which one did we get? We got the gradient of AR, we got the length, we got the coordinates of M, we got PM. PM, we got the equation of PM, but that doesn't help us. All right. Anyway, let's say A is X and Y. There must be another way. Maybe I'm just not seeing it. Okay. Let me put on my thinking cap. Okay, so I got this one's length. I've got a way. I don't know. Maybe I might be using. I see the rain is coming down here in Cape Town. I hope you guys can hear me here. Huh? Was it muted? Okay. Can you guys hear me? Is everything all right? The sound okay? All right. Let's try something, guys. I'm trying to think of a way. Let's look at this triangle here. The rain is coming down crazy here in Cape Town. Onliners, can you guys hear me clearly? They can't hear a word I'm saying here in this place because it's coming down cats and dogs. I know. Relax. We here in Lansdowne and it is pouring. It's pouring. It's crazy. All right. I'm trying to think here. Guys, I got a long way of answering this. I haven't yet found a shortcut.
To do this, use the equation of P in equals P in is parallel to an odd. So if you use the equation and you substitute the y.
It's not the same equation.
It's both parallel, so can't the equation be equal?
Equations can't be equal. Okay. Give me a screen. All right, here goes. All right, I'm going to look at this triangle here. I'm going to be using Pythagoras here. mr squared is equal to mr squared is equal to rt squared plus mt squared. Right, Pythagoras. So what is mr? mr squared is the square root. Watch here. So what is mr? mr is the square root of x2. We got m, we got r. So let's see. x2 minus x1 all squared plus y2 minus y1 all squared squared. So that's mr squared is equal to rt squared. Rt is also the square root of x2 minus x1 all squared plus y2 minus y1 all squared squared plus mt squared plus mt. What is mt? The whole of PM was 4 root 13 divided by 2 because we want half the midpoint. We want that piece is half of that, which is 2 root 13, which is plus 2 root 13 squared. All right, let's see. Let's see. I'm just using Pythagoras. You people might have found an easier way, which I'm not seeing at the moment. Because if I use gradient, I'm just trying to think. Maybe the method that I'm using is a long way. Maybe there is a shortcut. Let's see. y2 minus, I can't. I got the gradient here. I got the gradient here. y2 minus y1. Any relationships here? I'm not seeing any other way. Let's see our onliners. Onliners, are you seeing any other way? Can't sir just use RT? RT what? You're asking me, okay, Giga says, can't I just use RT? We don't have the equation of RT. We don't even have the distance of RT. We don't have the distance of RT, so we won't be able to find n. What do we have in RT? Nabila, have you found a shorter way? Has anybody found a shorter way? No. Okay, so then let's do it this way. Let's use Pythagoras. The square and the square root will cancel out. So n minus 6 squared plus minus 16 squared. Minus 16 squared is 256 is equal to square and square root will cancel. You left with n minus 10 squared plus 256 again plus 2 root 13 squared. $52. Okay, so here goes. Now we need to solve for n. This is a quadratic equation. Watch here, guys. Watch here. Plus 256 minus 256 will cancel out. So we left with n squared minus 12n plus 36 is equal to n squared minus 10 times 2 minus 20n plus 100 plus 52. So n squared minus 12n plus 36 minus n squared plus 20n minus 100 minus 52 is equal to 0. N squared minus n squared will give me 0. Minus 12n plus 20n will give me 8n. Plus 36 minus 100 minus 52 is equal to minus 116 is equal to 0. 8n equals 116. N equal, whoa. 116 divided by 8. No. We get 14,5. Why? That squared, mr squared, mr, n minus 6 squared plus minus 3, minus 13 minus 3 squared is equal to, so mr squared is equal to rt squared. It's n minus 10 squared plus minus 13 minus, it's minus 3 because it's y2 minus y1 over x2 minus x1. I made a mistake, guys. Okay, so I did an algebra mistake, not a formula mistake. Let's go back. My mistake is here. My mistake is here. You see, x2 minus x1 all squared plus y2 minus y1 minus minus 3 is plus 3. That's where my mistake was. Okay, let's go back. Let's do it again. Now we have to get the answer right this time. N minus 6, so that and that cancelled out, so we left with n minus 6 squared plus minus 16 squared was 256 is equal to n minus 10 squared plus, now this is minus 10 squared is 100 plus, what did we say? What was this? 2 root 13 squared, which gave us how much? 52. Very good. Has to work now, guys. I swear it has to work. Let's go again. N squared minus 12n plus 36 plus 256 is equal to n squared minus 20n plus 100 plus 152. Let's go again. N squared minus n squared is gone. Minus 12n, there we go, plus 20n, there we go, that's out, is equal to 100 plus 152 is 252 minus 36 minus 256, the moment of truth. So, minus 12 plus 20 is 8n is equal to, let's go, 252 minus 36 minus 256, like a boss, minus 40. N equals minus 40 divided by 8, minus 5. That was your higher order question. The last question where you had to show that n was equal to minus 5. Look, I can't find a shorter cut than using Pythagoras there. I can't. I haven't seen it. If you see it, if any of the teachers online see it, good for you. Show your children that. But this is all that I see. I just used Pythagoras and I got it right. Did anybody else find a shorter cut to this? Okay, yeah, that's why. So here we go. No shortcut. I haven't found a shortcut to this problem. That's why I just used Pythagoras. Okay, now n is equal to minus 5. So you guys got this? All I did, I substituted into Pythag. We got quadratic equations in terms of n, and we solved for n. The algebra took over. After we substituted, the algebra took over. It's perfect. Thanks, Aman. We got 5 minutes before break, 5 minutes before lunch. Give me the area of triangle RMT. Then we're done. Then we into break. Beautiful question. Made us think a little bit. Got me sweating. Not too much. Yeah. Huh? I'm telling you. Nice question. All I did was Pythagoras in that triangle. I used distance formulas. And we got values in terms of n. Yeah, it was a bit of a heavy one. You can't expect everything to be easy. Right. Last one, before break, before lunch. Last question before lunch. We got a 1 hour lunch today. 12:30 to 1:30, Salah and lunch. Let's do the last one, guys. They wanted the area. They wanted the area. Right, what is area equal to? We're doing the last question. The area of triangle RMT. So we know area is equal to half base times perpendicular height. Area is equal to half. What's my base? RT. So this was -5. So half RT multiplied by MT. So which is equal to half. RT is the square root of x2 minus x1 all squared plus y2 minus y1 minus 3 all squared times MT. MT is 2 root 13. Remember, 4 root 13 was the whole of PT. PT was equal to 4 root 13. So MT is equal to half of that, 2 root 13. Let's go to our calculators. A half into the square root of minus 15 squared is 225 plus minus 10 squared is 100. Close brackets, open brackets, 2 square root 13. Close brackets. Boom. 65 units square. Game over. Time for lunch, boys and girls. Time for lunch. I'll see you guys back in here at 1:30 on the dot for Euclidean. Enjoy your lunch. Enjoy your lunch. I hope you guys enjoyed the session. We did a lot of work. Well done to all of you. I'll see you guys at 1:30. Onliners, stay sharp.
Just for those students who are on site, the lunch will be here in 5 minutes with Adam.
Okay.
So just 5 minutes. And for those who will be doing the interviews, they can come to me now, but we'll do the interviews at 1 o'clock.
Excellent. Thank you. Thank you, Khalid. See you guys. See you guys. See you guys. Lunchtime.
It is the Awqaf SA Grade 10 Maths Workshop live from Azhar High School in Athlone, Cape Town, with myself, Khalid Kungani Kivaspati. I'm with Alia Isaacs and Rodia. Starting with Alia Isaacs. Alia, welcome to Awqaf SA.
Hi.
Okay, that's a bit nervous. Let us try that with Rodia. Rodia, welcome to Awqaf SA.
Hi.
I don't know why you guys are like this, but if I must say that you guys are one of the loudest here today. Starting with you, Alia, how have you found the workshop?
The workshop has been really nice so far, and we covered a lot of work. And yeah, I cleared all the points where I was missing for the certain topics.
Are you enjoying the workshop
I'm enjoying the workshop very much.
and the burgers?
The burgers, I love their burgers, but then they rob me with the chicken. They rob me with the chicken.
But no one chooses the burger for you.
No, I'm always unlucky. I knew I'm gonna get robbed with the chicken.
Guys, and now we also have Rodia. Rodia, are you enjoying the workshop?
Yes, I'm enjoying it. I find it very useful and learning things that I can't forget. I find it very useful.
Whatsoever you have learned here today, would you be able to teach it to the next person?
Yes, I would.
And also, a lot of people who come here for the Awqaf SA workshop, and they will have that feedback that, I've got that improvement on. Have you seen that improvement yet? Or it's yet to come?
So, previously, there was a workshop, and I found it very useful. My marks increased by a lot, actually. I find it useful.
That's very, very encouraging. And to you, Alia Isaacs, have you found any improvement in your marks?
Okay, I stayed consistent, but that's a good thing also because of new topics. And then I stayed consistent with my marks. So yes, I have found it actually really beneficial, and I use it to practice at home with YouTube.
When you say consistent, do you mean that you are on that 90% plus mark?
Yes.
Oh, that's very, very encouraging. And where do you see yourself in the next 10 years?
Okay, so it's detailed. I see myself in sitting in a cafe with a cappuccino, working on my laptop, studying for actuary exams.
In 10 years? Wow, I mean, and then for you, Rodia, where do you see yourself in the next 10 years?
16 years. I see myself enjoying my time with my family and in university studying. I actually want to be an accountant.
Now, when you say that you'd like to enjoy your time with your family, you need to be a little bit specific there. The family you already have or the one you're going to make?
The one I'm going to make.
Okay, she says the one she's going to make. So in the next 10 years, Radia sees herself, she wants to be an accountant and she sees herself with the family that she's going to make, inshallah. Amin for that. And that's it from Alia Isaacs as well as Rodia. And now we have two students. Thank you very much, ladies. We have now two gentlemen, one from Oracle Academy and the other one from Darul Islam. Starting with you, Yasin. How are you today?
I'm good, and you? Thank you.
You are always good, or is it that you always act as if you're good?
Nah, I'm always good, always fresh.
How have you found the workshop today at Awqaf SA?
It was very nice, especially Mr. K. Nah, he's good, he's good. He make me understand very quick. I love you, Mr. K.
When you say that Mr. K made you understand very quickly, does that actually mean that whatever Mr. K has taught you today, you can relate it to other people?
Yes, and not to speak bad, Mr. K, you beat my math teacher. I always say that last term, and I'll say it again.
And on my other side, we've got Ishaq. Ishaq, welcome to Awqaf SA.
Thank you for letting me be in the interview.
How are you feeling today? You look nervous for someone who's been talking throughout here. You look so nervous.
Yes, I am very nervous. I said my first time being in an interview with, I say, and famous people.
What do you mean by famous people? There's no one who's famous here. You, the one whom we are focusing on. How have you found the maths workshop today?
The Max workshop was now very helpful. Mr. K taught me he taught me that stuff my teacher couldn't explain to me, and now I understand it very well now.
You understand it very well. What is it that you can go and perhaps teach to whomsoever was not here today?
And I can teach majority of the stuff in I taught. I'll be able to explain it now better to the people, and and also now do more on sums that I couldn't do before.
Coming back to you, Yasin, where do you see yourself in the next 10, 15 years?
10 years, I see myself owning my own dentistry practice, inshallah, amin, and having apartments on the sideline.
When you say dentistry, do you mean that you are the doctor there, or you will just buy, a company that's already going?
Doctor there, then inshallah, have around Cape Town.
And then as for you, Ishaq, he wants to have his own dentist, an optometrist.
Now I want to be an architect. Architect, I'm going to join my uncle and now work with him, build houses and stuff.
Because we've got terrible buildings here in Cape Town in the last 10 years, so we don't actually need those. Thank you very much, gentlemen, for joining us. And for those who are joining us online or who perhaps just came online, it is the Awqaf SA Pure Maths workshop that is live from Azhar High School in Cape Town, Athlone. If you have missed a little bit, do make sure that you go to Awqaf SA's YouTube page. That's where the video is available immediately after the stream has ended, and you can learn whatsoever you may have missed. And do not forget that in January, we do have that competition that will be going on, whereby you need to register or upload your marks, and we need to see that improvement, and you can stand a chance to be one of those 4 people who will be getting that hard-earned cash from Awqaf SA. And that's it from me. From now, we will wait for Mr. Kota at 1:20. Do make sure that at that time you are tuned in. Up until that time, I'm off.
The Euclidean. Onliners, are we back? Everybody in, everybody in. Yeah, they're complaining about the music, the background. Welcome back, welcome back, welcome back. I hope you guys enjoyed your break. We are in for the last session. Hope you guys can hear me and see me clearly. And let's get cracking, guys. We're into the last session. Hope you guys enjoyed today. Onliners, you guys are the best. Lots of love coming here from cold and rainy Cape Town. Let's go. Right. Not so cold, but yeah, windy and raining. Right, a wet Cape Town, guys. How's the weather there around the country? Hit us up, tell us how you guys doing across the country and which province you guys are hitting us up from. Talk to us. We'd like to hear your story. Okay, guys, we're starting with Euclidean. Euclidean geometry. Let's start with Euclidean geometry. The main thing that you guys got to remember for this year, obviously, is the very important theorem that you need to learn is the midpoint theorem. So take this down, the midpoint theorem. Remember, we're going to be dealing with triangles. We're going to be dealing with triangles. And what type of triangles are we going to be dealing with? Isosceles triangles, 90-degree triangles. We're going to be dealing with, in triangles, guys, we're going to be dealing with a little bit of congruency. Take this down. That's in triangles. And obviously, if we're dealing with 90-degree triangles, we'll also be dealing with some Pythagoras. You're also going to be dealing with parallel lines. So we're going to be dealing with corresponding angles, alternate angles or alternating angles, alternate angles, and what we call co-interior angles. We're also going to be dealing with palms, parallelograms. Right? The type of palms that we're going to be doing is a normal parallelogram. We will also be dealing with a rhombus. Right? A rhombus is a tilted square. We're going to be dealing with squares and rectangles. Squares and rectangles. So you need to know the properties of all of these, guys. And then maybe you might get to use a kite. Or you might get to use a trapezium. But main thing, let's talk about what we're going to be talking about now is the midpoint theorem. So this is all your basic background knowledge that you need to know for grade 10. Onliners, how are we doing there, guys? Are we back and are you ready? Are you ready for action? Yeah, we just started, guys. We just started. We're back from the break. This is our last session. We'll be pushing through. We've had a request to finish off at about between 2:30 and 2:45. So we'll finish off by about 2:30, 2:45. Okay, let's go. The midpoint theorem. You've got the midpoint theorem. You've taken all this down. Let me explain to you, very important, the concept of the midpoint theorem. So I'm erasing all of this, guys. Let's draw a triangle. Let's see. Let's draw a triangle. There we go. And a line parallel from the midpoint to midpoint. So here we go. Right. Take that diagram down. Take that diagram down. Let me explain to you what does the midpoint theorem mean. Okay, so we can call this triangle A, B, C, D, E. Right. Here's the midpoint theorem. This is what it states. And I'll show you how we're going to apply it. Right. A line, we're talking about BE. So this is the midpoint theorem. A line, we're talking about BE. Drawn from the midpoint of one side of a triangle so there we go, a line BE drawn from the midpoint of one side of the triangle AC to the midpoint of its opposite side, to the midpoint. So from midpoint to midpoint, right? So one side of a triangle, a line BE drawn from the midpoint of one side of a triangle to the midpoint of its opposite side. Opposite side, which is the opposite side here? AD. Right. Now what about it? So a line drawn from the midpoint of one side to the midpoint of another side is parallel to the third side. And half the third side in length. Meaning that if this is 100 units, then BE will be 50. So we're talking about the line BE, guys. A line drawn from the midpoint of one side to the midpoint of the other side is parallel to the third side and half. So there's two things about the line. It's parallel to the third side and half the third side in length. So not only, this is the theorem, not only do we need to know the theorem, we also need to know the converse of it, the opposite of it. So I'm going to write the converse of this as well. Guys, learn the proof for 6 marks in your paper. And that's bookwork. You can ask your teacher in school. I'm not going to do the proof for you. Right? Learn the proof of the midpoint theorem. It's examinable. It will be asked. Right? Ask your teacher. Okay. Learn the proof. They'll ask it. It's in your textbooks. Those of you using the Mind Action or Classroom Mathematics textbook or even the Platinum textbook in school, it's in your textbook. Just learn the proof. then ask your teacher. Your teacher will definitely have the proof. Ask them to learn so that you can learn the proof and you can answer it. You'll get 6 marks for free. Okay. Onliners, we okay? I want to write down, I want to clear the frame. Yes. And half. Yes. Okay, let's go. Now let's write, I'm going to clear the frame. I'm going to clear the frame. I'm going to clear the frame. And now let's do the converse of it. Right, now we're going to do the converse, the opposite of the midpoint. You need to know both. Now we're going to write the converse of midpoint theorem. Right, again, A, B, C, D, E. Right, so the converse is, the opposite is, right. In the first one, now let's talk about BD. If a line goes through the midpoint of one side, goes or is drawn. Let's say is drawn. If a line is drawn from the midpoint of one side and now they tell you it's parallel to the third side and parallel to the third side, it will bisect the opposite side. It will bisect, means cut in half, go to the midpoint of the opposite side. Meaning that if this line now is given to you, that it goes from the midpoint of one side parallel to the third side, that means it must be drawn. That means point D is the midpoint of the opposite side. So in the first scenario, the line is drawn from midpoint to midpoint, therefore it's parallel and half. Now if a line is drawn, the converse is if a line is drawn from the midpoint parallel, that means it must be drawn to the midpoint of its opposite side or it bisects the opposite side. Important. You're going to see how we apply it now when I start doing problems with you. Let's first start off with the parallelogram. Let's start off with the parallelogram problem. We'll end up, let me see if in this paper, yes, they ask you the next question to prove the midpoint theorem. So that obviously is bookwork. It's another 6 marks, free of charge. For nothing. So that means we were sitting on 76. Even if we just learn the theorem, we're sitting on 84. If we get the next problem right, we got 90. We get the last problem right, we get our 100. Right. Let's talk about the parallelogram problem. So this is a midpoint problem. Okay, before we do that, let me give you a midpoint problem to do. Let's do an application of this. How could they ask you, besides the proof? The proof, it's marks in the bag already. 6 marks. And remember in Euclidean, you can only construct in a proof. When you're proving a theorem, that's the only time you construct. Other than that, you don't draw any extra lines. You take and you work with the shape that they give you. Okay. So let's start with one like this. Let's draw, let's draw this, guys. Take this one down with me. We draw a pyramid. There's a pyramid in Egypt, the Egyptian pyramid. Now, let's draw some lines. Let's draw one line going like that. And let's draw one line going like that. Take that down. This is point A. That's point B, C, D, E, F, G. Okay. I tell you that this is 80. I tell you that side is equal to that side, and that side is equal to that side, right? I tell you that AD is equal to 60 units. Then I tell you that that is parallel to that. And I tell you that AG is equal to 90 units. AG is 90, so that whole side is 90. I tell you AD is 60. I tell you AD is 60. Okay, question number 1. I want the length of BE. Question number 2. I want the length of AE. Question number 3. I want the length, with reasons, the length of FG. And I tell you that EF is equal to 20 units. EF is 20. And I want the length of DG. Now you can clearly see just from the diagrams, we're dealing with triangles, we're dealing with midpoints, so we know this entire problem has got to deal with what? Midpoint theorem. Or the converse of it. Either the midpoint or the converse of it. Okay, the length of BE. Now we know this line BE is going from the midpoint of one side to the midpoint of the other side. I can't just say it's 40. We know BE is going to be half of this. We know BE is going to be 40. It's going to be half of 80. But how do we write it out? No. Firstly, no. Listen. Let me show you how to write it out because it's worth 4 marks. So obviously they want you to write out how you got it. So the answer to question number 1, you're going to say AB is equal to BC given. AB equal BC. Then AE is equal to ED given. Therefore, BE is parallel to CD and half CD in length. And that's what we call the midpoint theorem. Now we write midpoint theorem. Therefore, BE is equal to half of 80. Now you can say BE is equal to 40. Let's call it centimeters, 40 centimeters. Done. And that's why you will get 4 marks. So now it is parallel. So this line is now parallel to that line. And half that line in length. Are you all following me? Right. So we got BE. The length of AE, come on, AE. We know this whole length is 60. So AE is half of that because this E is the midpoint. So what is AE equal to? 30 centimeters. Half of 60. The answer to question number 2. The answer to question number 2, AE is equal to 30. So if AE is 30, ED is also 30. So we got that. That was 2 marks. Find the length of FG. Now we know FG is going to be half of 90, which is 45. But you need to prove it. Because this now is not the midpoint, it's the converse. This line is parallel going from the midpoint. So now watch what we do. We have to write out. So I'm going to erase here. So let's answer question number 3. Right. AE equals ED. AE equals ED. Given. EF is parallel to DG. EF is parallel to DG. Given. Therefore, AF is equal to FG. That means AF is equal to FG. And it's not the midpoint theorem. It's the converse of the midpoint theorem. Therefore, we want FG. FG is equal to FG. F is the midpoint, half of 90. FG is equal to 45 centimeters. So that's 45, and that's 45. Now, to answer question number 4, DG is equal to 2 times EF. And you proved the midpoint theorem. Because if this is 20, DG must be 40 centimeters. Therefore, DG is equal to 2 times EF, which was 20, which is equal to 40 centimeters. So, length of FG, that was another 4 marks, and this is another 2 marks. You can clearly see 6 and 6, 12 marks just on this diagram. So if we were on 78% plus 12, how much are we sitting on for the paper already out of 100? 90. Here's your last 10 marks coming up for this paper. And then we got 100. That means we've just clocked the paper. Okay? This is how you clock your papers. This is how you get 100. Just know your work. And if it's a 2-hour paper, you want to finish up the paper in about 1.5 hours, 1 hour 35. Worst case scenario, 1 hour 40 minutes. The last 20 minutes, you want to be done with the paper, checking your paper, making sure you haven't made any errors. Because sometimes you can get so excited in the exam. You saw what happened to us in that analytics. A simple thing like a sign threw us out completely. If I didn't go back to check that negative had to become a positive, remember minus 13 plus 3. I had minus 13 minus 3. Knocked us out completely. Can make you fail. A sign that you are out in math can make you fail. So please be careful with your positives and negatives. Onliners, how are we doing? Are we doing good there, guys? Number 3 for how many marks? 4 marks. Yes. Excellent. You guys are working like machines. Let's go. No, we don't need to answer that question. Right, can I raise here? Right, here goes. Take the next question down. Take the next diagram down. Let's draw it. Okay. Now this is a bit of a challenge. It's going to rock your brain a little. Right, take this one down, guys. Now there's three triangles within a parallelogram. Right, so they say that point is R, Q, Q1, Q2, V, V1, V2, V3, T1, T2, S. They tell you that side is parallel to that side and that side is parallel to that. So obviously RSTQ is a palm. It's a parallelogram. Okay. Right. They also tell you that this angle is X and that angle is also X. That means this line bisects the angle. These two angles are equal, and they say that angle is equal to that angle, and that's Y, and that's also Y. Okay. For 6 marks, your first question, prove that V2 is equal to 90 degrees. Angle V2. You need to prove that that angle is right angle, is 90 degrees, and it's worth 6 marks. Interesting. Interesting. S is equal to 2RQ is equal to 2 of RQ. And then the second question for another 6 marks. Prove that RS is equal to 2RQ for 6 marks. 6 and 6, 12 marks. Interesting stuff. Interesting stuff. Now we got to start. Leave these big diagrams for last in your paper. Make sure that your data handling, full marks. Analytics, full marks. Trigonometry, full marks. Trig graphs, full marks. Your basic Euclidean, full marks. Higher order you leave for last. If you got time, you do it. You'll still get 95 or 90% for your paper. If you don't have time, leave it out. It's fine. Just make sure what you did before, you've banked 90% of the paper already. Now, these are our higher order questions. Who's proven that V2 is equal to 90? We need to get, they haven't given us any values of any angles. So that means we got to use our laws of a triangle, or we got to use our laws of a parallelogram to prove that V2 is 90 degrees. It's 2 o'clock already, guys. We're going to go on for 30 minutes. We've had a request from the principal, especially of the school year, that we're going to go till 2:30. Right, let's go. Let's see. I'll give you guys I'll give you a couple of minutes. Apply your mind. See what you guys are coming up with. If you're sitting at schools with your teachers, 12 marks here, guys. Let me see. Prove that RS is 2 times RQ. I'm not sitting here with a memo, so let's have a look at what can it be. Are you guys suffering? Yeah, we have to prove it. V1 is equal to Q2, which is equal to X. That's going to help us, Sir Collins maths class. That's going to help us with our second one. That's not going to help us with our first one. You think V2 is 90. They're telling you it's 90. You just need to prove it. You don't need to think. Let's check. All right, let's see. Come, let's all do it together. Let's apply our minds. Right, because this is a parallelogram, I know that this angle plus that whole angle, co-interior angle, is equal to 180. Angle Q plus angle T is equal to 180 degrees co-interior. Co-interior are supplementary. Pay attention. Now what is Q equal to? X plus X, which is 2X, plus angle T. Angle T, Y plus Y is 2Y, is equal to 180. Now if I divide, watch here. Boys, can you guys pay attention? Thank you. Divide by 2, let's simplify that. If I divided everything here by 2, just to simplify, I'm going to have X plus Y is equal to 90 degrees. I'm going to call that one equation number 1. Now I need another equation in terms of X and Y. So simultaneous equations. Why? Because I got two unknowns. Right, Ramadan? I got two unknowns. Right. Where's my other equation going to come from? Shh. Let's look at this triangle. Sum of angles of a triangle. Isn't it V2 plus Q2 plus X plus T1, which is Y, is equal to 180. This is triangle VQT. Sum of angles of a triangle. Right. But what is X plus Y from equation number 1? But X plus Y is equal to 90 from equation number 1. So therefore V2 plus, instead of X plus Y, let me just highlight it for you. There's X plus Y, there's X plus Y. So instead of X plus Y, what can I replace it with? Plus 90 is equal to 180. And now I just solve for V2 because I have to prove that it's 90. So take this 90 on the other side. Therefore, V2 is equal to 180 minus 90. V2 is equal to 90 degrees. Done. There we go, simultaneous equations. Whenever you have X and Y, you want two equations. The first equation we got from our parallel lines. The second equation we got from sum of angles of a triangle. And we just solved simultaneously. We just substituted. There's your first 6 marks. Onliners, do you see it? Does it make sense to you? RQT plus QTS is equal to 180. Co-interior, yes, correct. Correct. V2 is now 90 degrees. Absolutely, well done. Now let's see you guys do number 2. Prove that RS is 2 of RQ. Prove that RS is 2 of RQ. Well done, well done. Nabila, you did it the same way. Let's erase. Can I erase here? Right, let's answer question number 2. Let's see. Let's see. What do we have? What do we know? Okay, if this angle is angle X, then we know that that angle there is angle X, alternate angles. If this angle is angle Y, then we know that that angle there is also angle Y, alternate angles. How does that help our cause? Right. So if this is X and that is X in that triangle, that's isosceles. So this side is equal to that side. That's an isosceles triangle. I know. But now we need to get to this. Now watch here. This is a parallelogram. So that means this side is also equal to that side. And if that is y, that's also an isosceles triangle. That means these two sides are equal. That means that is the midpoint. Therefore, RS is 2 of RQ. Because this could be called RQ, they are equal. And that also could be called RQ because they are equal. Therefore, RS is 2 of RQ. Beautiful. So let's go all the way back. I'm starting it all over again. Because now we need to write out. Now that I know how to get to the answer, I just need to write out logical steps with reasons. Okay. So let's make it make sense. So that means V1 is X, right? So now I'm answering question number 2. I'm going to say angle V1 equals X, alternate angles. Therefore, triangle RQV. I'm just going to do it in a different color. That triangle is isosceles. Triangle RQV is isosceles. Therefore, RQ is equal to RV. Right. The sides opposite the equal angle, sides opposite the equal angles of an isosceles triangle. Right, so we're done with that. Now let's look at let's look at that triangle. Okay, so we got V1 equal X. Now we're going to say V3 is equal to Y. Alternate to T1. V3 is equal to Y, alternate angles. Right. Therefore, triangle VST is also isosceles. Because now we got two angles to be equal. All right. Therefore, ST is equal to VS. ST is equal to VS. The sides opposite the equal angles. But this is equal to that is equal. Therefore, these are all equal. Therefore, RQ equals RV equals ST equals VS. They are all equal. Therefore, RS, that long side, is 2 of angle RQ. Right? RS is equal to RV plus VS. Therefore, right, which is also equal to RQ, right? RV is equal to RQ is equal to VS. Therefore, RS is equal to RQ plus another RQ because these two are equal. Therefore, RS is equal to 2 RQ. There's your final answer. You need to apply your minds for these ones. Here's another 6-mark question. One more. Again, like I said, these are the higher order questions. I can't sit here the whole day doing higher order. You got to apply your mind, apply what you have. You got to work through your past papers. But I'm just showing you how it all pulls together. We did that one on the midpoint theorem. Learn that one. Here comes another one with midpoint in it. The last question of this paper. The last question of this paper, which is also going to be the last question we're going to do for today. I know it's Sunday. I know it's been a long day. Now that you understand the work, you need to work through your past papers and you need to practice. You need to sit with 2, 3 of you sitting together. But like I always say, if you 3 people studying together, 2 can't be domcops. You will all fail beautifully. It will be the blind leading the blind. Imagine 3 of you parking and all 3 of you are domcops. Yo! You got big trouble, bruh. Right, let's go. Take this diagram down. Now, I haven't done this problem. First time I'm seeing this problem. Remember, it's very rare that you're going to see a problem, especially in Euclidean, that you've seen before. Yasin, you paying attention? It's very rare that you're going to see a problem that you've worked on before, especially in Euclidean. They'll always try and give you new shapes because they want to test whether you can apply your knowledge to that shape. Right, here goes. There's your shape. There's your shape. This is point P. UTQ, UTQ, SR. They tell you that piece is equal to that piece, that is equal to this, is equal to that. Whenever they show you like this, it means that these little segments are all equal to each other in length. This point here is point V. And they tell you from U to V, they tell you UV equals X units. UV is equal to X. From there to there is X. Anything else? No. In triangle PQR, QT equal TU equal UP. Okay, we got that. QS is equal to SR. We got that. And UV equals X. We got that. Find the length of VR for 6 marks. Find the length of VR in terms of X. Find the length of VR in terms of X. Okay. That's your last 6-mark question. That is your last 6-mark question. Let's see. I have come across one where they gave you a circle and they asked you for Pythagoras. I'm going to try one like that after this, if we have time. But it's 2 already. Let's see. Let's see if you guys can work this one out. It's worth 6 marks. Okay, I haven't seen anything like this before, but in any case, let's see what do we have here, guys. What do we have? I know that that is X. I got a triangle here. I got equal, 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 equal. That means I must have a parallel line. Here's midpoint theorem. So let me highlight it for you. Okay, let's do it in red or maybe blue. Let's highlight this triangle. Let's highlight that triangle. Look, I don't know how to get to VR yet. I don't know how to get to VR yet. But what we have identified is the midpoint theorem. Okay. So in this triangle, we got this line from the midpoint of one side to the midpoint of the other side. That makes, whoa, wait, no, can't use that triangle. Okay. I'm not going to look at that triangle. I'm looking at this. Let's look at this triangle first. Let's look at triangle PTS, post-traumatic stress. Right, let's look at triangle PTS. This is the converse. But again, it's not, do they tell us it's parallel? No. All right. Okay, guys. You see, again, we're gonna have to go to the big we're gonna have to go to that very triangle that I spoke about. Firstly, we're gonna prove the two lines to be parallel. Watch here. In this big triangle here. So I'm gonna say in triangle UQR. So we know that TQ is equal to TU. We know that QS is equal to SR. This is given. That's given. Therefore, TS is parallel to UR. PS is parallel to UR. Midpoint theorem. Right. So now we proved it to be parallel. Now let's go back. Let's go now to the other triangle. Now let's go to this triangle. Triangle TPS. So in triangle TPS, PU is equal to UT given. And we just proved that these two lines are parallel. And UV is parallel to TS. We just proved that. Proven. Therefore, TS is 2 times UV. Therefore, TS is equal to 2 times UV, which is equal to 2x. So now this line is 2x. Right? The converse of the midpoint theorem. What did they want? They wanted VR in terms of x. So now we know let's see in this whole triangle. So we know that UV plus VR UV, therefore, remember, we want UV plus VR is 2 times TS in this big triangle. In the big triangle, watch here, in the big triangle. In the big triangle. Remember, now this 2x here is half of this big line here. Or the big line is 2 times that because these two lines are parallel. The midpoint theorem. Right? So let's go. UR is equal to 2 times TS is equal to 2 times TS. right? Midpoint theorem. So UR is UV. So UR on its own. Okay, so let's just put here UR is equal to 2 times, what is TS? 2x. So UR is equal to 4x. This whole line is 4x. But what is UR? UR is UV plus VR is equal to 4x. They want VR on its own. So what is UV? X. X plus VR is equal to 4x. And here's your final answer coming up. Here's your final answer coming up. I don't think I'm right. I know I'm right. X plus VR is equal to 4x. Therefore, VR is equal to 4x minus x. VR is equal to 3x. There we go. There we go. It's a bit heavy. It's a bit hectic. But again, it's the midpoint and converse of midpoint theorem that you're applying. Again, I'm saying you want to be spending on these questions at least the last 15 to 20 minutes. Look, like I told you, I don't have a memo, but I'm telling you that in this triangle here, midpoint theorem, but they gave us that as x. The only way to prove that this was 2x was to prove that these two lines are parallel. So I had to go in this triangle here because they were only talking. That's why I started in triangle UQR. No, it wasn't UQR. Oh yeah, I proved in this triangle these two lines were parallel. Then I went back into this triangle. And because they were parallel and midpoint, that means this had to be 2 times that. Good. So if that was x, then this was 2x. Correct. Correct, correct, correct. So firstly, we proved parallel lines. We proved that the two lines are parallel in that triangle. Then in this triangle here, we proved that TS. We proved that TS is 2x, right? Then we went big to the big triangle again. We went to the big triangle. If this is 2x, then this here is half of that whole side there. UR is 2 times 2x, which is 4x. And UV plus VR is equal to 4x. There we go. VR is 4x minus x. VR is equal to 3x. I don't think we're right. I know we're right. Okay, as per the request from the school, guys, that has brought us to the end of the session. Guys, a nice big round of applause to everybody for being part. I know I don't want to take up your entire weekend. I hope you guys enjoyed yesterday and today. You guys are absolutely amazing. It's pouring here in Cape Town. We are there. We done. Assalamu alaikum. Good luck in your exams. Thank you, onliners, for being there. Stay strong. Let's get our 100% in our final exams. Jazakallah to Awqaf, our man Khalid, the school here, Al-Azhar, and all our online learners. Jazakallah so much for everybody. From myself, Muhammad Kota, Assalamu alaikum wa rahmatullahi wa barakatuh. We greet you with a universal greeting of peace and salam. Love you guys. Assalamu alaikum wa rahmatullahi wa barakatuh. Bye, guys.
And that's how we come
Salams, Farhan.
end of
See you next year, inshallah. See you. Assalamu alaikum.
A little bit earlier because
See you, Nabila. Walaikum salam.
Grade 12 students.
See you guys.
Will be writing
Ameen.
their exams. Do make sure that you join us. Do make sure that you are with us next year. You must forget that we've got that workshop
Enjoyed it.
that is coming up
Lovely.
in January. To make sure that you're part of that and do not miss out as well. From myself, as far as I am concerned, that's it from me. Up until the next time, see you all, you guys. Thank you very much.
In the year 2000, Awqaf South Africa was pioneered as an institute of Waqf